have the possibility to have some of those similarity questions tomorrow. These questions compromises following the setting, that is physical, inorganic, and the organic section of chemistry. To emphasize more, presently we are live on YouTube, Facebook, following the Acadex Conviction platform. For those that are watching live, please, I would like you to subscribe, like, and comment. And any question arises as the a question proceed. For those that are online, I would love you to send them through your comment section, which will be attended to you directly by Sir Godwin Yakum by himself. He will be with you guys. Those that are following through the WhatsApp page, for any question you want to ask, you can just unmute your mic, then ask the question. I will not be likely to read question 3 or 2 times because we're dealing with online students from the platform as well as we're dealing with students from here. So once I read a question, be keen and understand what I'm reading or what I'm saying, because I would not like to repeat myself 2 to 3 times. Okay, so we're going to be looking at, first of all, we're going to touch all the three parts of physics. Most will start with the physical part, which is what we always know, that is physical chemistry. Maybe the question I'll be answering today, some of you people have never come across that question, and some of you people maybe will not have the chance maybe to have seen such of the question. So I'm going to start. Okay. The following elements are given, that is carbon 12, hydrogen 1, oxygen 16, sulfur 32, aluminium 26. The Avogadro constant is equals to 6.02 times 10 to the 23. What do you understand by I1, amount of substance? The first question that they are asking you is, what do you understand by amount of substance? It's very funny. I believe that maybe you have never come across such questions since you have been answering the GCE. You just know that you have been hearing of substance, you have been hearing of mole concept, you have been hearing of atoms, elements, relative molecular mass, and so forth and so on. So now we're going to be looking at the amount of substance. What do you understand by amount of substance? Okay, we're going to proceed. I'm going to be giving you what I understand by amount of substance, and that is what I'll expect you to take as amount of substance. Good. Now, when you hear a substance, what is the first thing that comes to your mind? Because this question section is not just all about giving you the answers and cramming to go and write. Tomorrow you may face yourself with difficulties or questions that arises. And when those questions arises, you don't even know where the questions comes out from. You're just like, where are these questions from? What is happening? How is this question? What is this? What is this? You don't even know. So first of all, when you want to define something, you can define the word separately. For instance, we have amount and we have substance. When we talk of amount, what do we mean? We simply means what? How much or the quantity of what is contained. What is substance? A substance is just simply a mixture of several things. Now, what is the amount of a substance? Now, we want to define the term amount of a substance according to chemistry. Now, let us look at what is just simply amount of a substance according to chemistry. Good. So, the amount of a substance here is defined as That is the chemical composition of any element brought together by a mixture. The chemical composition of different elements brought together by a mixture. That is what we call the amount of substance. The chemical composition of elements or compounds brought together by a mixture. That is what we call the amount of a substance. Now, the next question says that we should define what do you understand by mole ratio? Another very funny question. What do you understand by mole ratio? What do you understand by mole ratio? This is another very funny question. I believe that when you have been answering your questions, you have not also come across such questions. So let us look at what we understand by mole ratio. First of all, what is a mole? For those that are following on the online session, that is a very important question for you to answer. You can do your answer in the comment section and we're going to view it through. Now, what is a mole? What is ratio? What do you understand by ratio? This is just what? The unit per fraction of every number. That is ratio. The unit per fraction of every number. So what is now a mole ratio? So we are simply talking about what? The mole per unit ratio of any mole. But you cannot define it like that in chemistry, and we say that you are actually correct because we have a broader definition of the mole concept. So how now do you link the definition of the mole concept to the mole ratio? So I'm going to define the mole ratio to you guys. Now let us start. Now let me define mole ratio so that you understand what a mole ratio is. Good. A mole ratio is just simply what? The proportional relationship between the numbers of molecules of many two substances involved in a balanced chemical reaction. What did I say? The proportional relationship between the number of moles of any two substances involved in a balanced chemical equation. It must be in a balanced chemical equation because it is from equations that we always get what we call what? Mole fractions. You cannot have a mole fraction or a mole ratio without having a balanced chemical equation. So it must always be from a balanced chemical equation. So I'm going to give this definition once more again. And I said a mole ratio is the proportional relationship between the numbers of molecules of any two substances involved in a balanced equation. Now, that is what a mole ratio is all about. So if we do not have a balanced equation, you are not going to get a mole ratio. So what did I say? The proportional relationship between the numbers of moles of any two substances involved in a balanced equation. What am I saying? The proportional relationship between the number of the moles of any two substances involved in a balanced equation. That is what we call the mole ratio. Now, the B part of this question says a solution was made by dissolving 9.0 grams of hydrate aluminum sulfate. Most of you people, you don't even know the chemical formula of hydrate aluminum sulfate, and they hardly give it. So I'm going to give you the chemical formula of hydrate aluminum sulfate, and you are going to take note of it. So the chemical formula of hydrate aluminum sulfate is given as Al2SO4 3 hydrate 6H what hydrate 6H. So this is a chemical formula of aluminum hydrate. When you hear aluminum hydrate, it simply means what? Al2 sulfate trisulfate times 6 water. That is the chemical composition of aluminum hydrate. Now, the question goes again. I'm going to read the question again. A solution was made by dissolving 9.0 grams of aluminum hydrate sulfate in 250 cm cube of solution. Calculate the numbers of moles of aluminum sulfate of hydrate aluminum sulfate. Now they're asking us to calculate the numbers of moles when we dissolve 9 grams of aluminum sodium hydrate into 250 cm cube of solution. Now I want to see how we can calculate that. So I'm going to first of all write down my data representation. Good. So first of all, the mass of aluminum hydrate has been given to us. That is, the mass of aluminum hydrate is equals to 9.0 grams. Secondly, the volume has been given to us. That is the volume of aluminum hydrate, 250 cm cube. Now, it is always advisable for us to convert volume to what? Decimeter cube, that's cm cube. Reason being that what? We are working in grams, so we cannot be working in grams per cm cube. It's not making sense. We are supposed to work in grams per dm cube. So volume will now be given from this to this, which will give us 0.025 dm cube. That's just simply divided by how many? You already know. I don't need to be telling you that. After this conversion, what do I do? What other data has been given to us? No other data has been given to us. And they want us to look for the number of moles of aluminum hydrate. What is the number of moles? Number of moles is equals to what? Mass all over. We also know that moles times volume is also equals to what? It's also equals to the concentration all over the volume. Now you can go by these two formulas and you still come out with the correct answer. So now I'm going to proceed by going with the first formula. So I'm going to be looking for the relative molecular mass of aluminum hydrate. So relative molecular mass of aluminum hydrate is given to me as what? What is aluminum? We already know aluminum is 26. So I have 26 times 2 plus sulfur is 32. Oxygen is 16 times 4, all that times 3. So what do I have? I have into sulfur, which is 32. 32 times this 3, because this 3 is definitely affecting sulfur. So you need to be careful. So it gives us what? 32 times this 3. So we have times 3 plus oxygen times 4 times 3. So that is 16 oxygen times 12. That's plus 16 oxygen times 12 plus 6 hydrogen times 2 hydrogen. That will give us 12 hydrogen plus how many oxygen? 16 oxygen. Now, we're going to do this mathematically, and we're going to have the relative molecular mass of aluminum hydrate. Unfortunately, my calculator is not here. Okay, good. Just press the button. Okay, so it's like the battery of our calculator is dead. Okay, the battery of our calculator is dead, so we go mathematically by the brain. 26 times 2 will give us 52. 32 times 3 will give us 96. So we have 52 plus 96. So 52 plus 96, that's 8. 5 plus 9, that's 14. So what do we have? We have 100 and we have 148. 148 plus 16 times 12. Our calculator is bad. So I'm continuing with my brain. That's 148. 16 times 12. 16 times 12 give us 192. 192 plus 148 will give us 340. 340 plus 12 plus 16. That's plus 28. Which gives us 368. So the relative atomic mass of aluminium sulfur hydrate is given to us as 368. So that's our relative atomic mass. Now we have our mass and we have our relative atomic mass. But now, what do we do? It means that the number of mole will now be equals to what? This is where most of you are always confused. Now, I can now say the number of moles in this case will now be equals to what? That will be mass all over molar mass. But do I know my molar mass? No, I don't know my molar mass. But do I have an Avogadro's constant? Yes, I have an Avogadro's constant. Now, most of you will just come and sit. You don't even know what to do. But 368 is also known as what? The molar mass of the compound, which is also known as the relative molecular mass. So this now is given to me as 9 divided by 368. And the number of moles will be equal to, so we have 9 divided by 368. Which gave us 0.024 grams or 0.024 moles. So that's the number of mole of aluminium sulfur hydrate. Like I said, the formula for aluminium sulfur hydrate is given to us as well. Aluminium 2 times times trisulfate dot 6 water. That is the formula for aluminium hydrate sulfate or hydrated sulfate aluminium, anyone. So this is what you are supposed to do to have the relative, to have the number of moles. Now the question continues. The number of moles, the number of sulfate ion in the solution. Now we are looking for the number of sulfate ion in the solution. How now do we get the number of sulfate ion in the solution? That is now where now the question is coming from. So now we are now concentrated only with what? With the sulfate compound. Now, so I need to first of all look for the numbers of atoms present in the sulfate compound. From there, I will be able to get the numbers of moles that are present in the sulfate constant. And how do we go about that? That is just simply going through what? The Avogadro's constant, which we now see that what? The number of moles N will be equals to what? Mm times L. Mm times L, which will give us what? The number of sulfate moles that are present in the sulfate compound. I don't think that arithmetic is something we should also be deliberating on for so long. With the formula, I believe if any matter arises, you can throw the question to me and I'll clarify your doubt directly in the group or in the comment section. One is how do we do that?
Who is that already?
Who is that with that sound, please? Please stop that sound.
Mute the mic.
Mute your mic. Please mute your mic to stop that sound. Has it stopped? Please mute your mic. Mute your mic. There's an online session going. Who is that now? Where? Sorry for that interruption. We are going to consider it as a break before I continue. Don't know what is bothering the student. Please, it's easy. Mute your mic. Who is making that sound now? Unmute your mic only when you want to ask a question. I would not love to be hearing that kind of sound in the background. Okay, so we are moving to the next question before that rudely interaction. There's the next question. I ended on the calculations of the mole. So I'm going to the next question. Okay, this is it. Good. Now let us be looking at the next question, which is the next section that has to do with the concentration of the aluminium in hydrate aluminium sulfate in mole per dm³. I already gave you everything before even reading the question. I said concentration is equals to, that is C, is equals to the number of mole times the volume, which we already converted this volume in dm³, which gave us 0.025 dm³. So what was the number of moles? That was 0.024 moles. So what is the concentration? Concentration therefore will just be simply equals to what? 0.025 times 0.04 in mole per dm cube. Are we together? That will now give us what we want in mole per dm cube. That will be the concentration. Now, divided by, please, number of mole divided by volume. You see how you are making me I'm tired and you're confused. Sorry, I'm sorry for that disturbance. Numbers of moles divided by volume will be 0.025 divided by 0.004, which will give you a mole per dm cube, which is roughly 0.1 or 1, no, that's roughly 0.99 mole per dm cube. Do the calculation. That's what you should be having. Now, the next part of the question says, a sample of oxygen consisting mainly of isotopy oxygen 16 and was enriched with oxygen 18. The composition of the mixture was 0.5 grams oxygen 16 and 0.25 grams oxygen 18. Calculate the RMM in the sample. This is very simple. We already know that the RMM of this sample is already something that is simple, because we are talking of what? A percentage that is already summing up to 100. Because when we take 0.75 of oxygen and 0.25 of oxygen 18, the RAM is just simply given to us as what? The first one is what? 18 or 16. That is 16 times what? 0.75 divided by 100 plus 18 times 0.25 divided by 100 will give us what? The RAMM of that composition. Are we there? Somebody said he has a question. Yes, please speak a bit aloud. Speak aloud. Speak aloud. Let me get your question, please.
Yes, speak now.
The doubt is clarified. So ask the question. Let me get.
I'm thinking that is seeing that oxygen on the whole electrolyte activity. I'm thinking that they will use the number of oxygen that we divided by the grams times 100 for the 1.60. Then you do same for the 18. This one I am multiplying it.
Okay, do it the same way. Let's see if it will not bring you back to the same thing. It will still bring you back to the same thing. Are we together? Yes, it will still bring you back to the same thing. It doesn't change anything. It's just that I'm multiplying it by this side. It's not changing anything. Yes, it's not changing anything. So that's it. Do it and sum up, and you are going to have the RAM. Are we together? So the doubt has been clarified. Okay. While waiting for the comment sections to clarify their own doubt, let us continue. The mass spectrum sketch of the sample of vaporization oxygen is as shown below. So I'm going to show you the mass spectrum sketch of this sample, which is as shown below. So you both should look at the diagram very well. Are you sure you are not seeing the board, boy? Looking at your screen, I'm seeing the board so well. Are you seeing the board?
How do you know that you are not seeing the board?
You see? You are seeing the board. You're just disturbing me now, boy.
So this way, I'm not seeing some kind of
Should we put blue light?
Should we put it on a blue light?
Yeah, just try it.
Okay, switch it to a blue light. Let's see. Is it better?
Yeah, better.
Better like this?
Because I'm seeing how you're sketching.
Okay.
Yeah, it's clearer. It's clearer.
It's better like this, right?
Someone is commenting here that I told them to come to YouTube because those on YouTube are having a very clear view.
Yeah. Some of you that can get to YouTube is also nice because those on YouTube has a very clear view. That's what some of our comments were receiving in YouTube now.
Okay, let me try it.
Some of your students are already on YouTube. They are having a good comment. They are having a good comment section on YouTube. Yes. Even I can also see Quincy Pluck. She's on YouTube. Please don't forget to like and subscribe on YouTube. Thank you.
Okay.
So I'm giving a spectrometer of this. Okay. Now, what does the x and the y axis represent? Now, I want to know what the x and the y axis represent. Now, when you look at the y axis, what do you think it will represent? When you look at the x axis, what do you think it actually represent? So on a mass spectrometer, what do we draw? We are plotting a graph of what against what? That is the first thing you should know. If you do not know what we are plotting against one, then you will never know the representation of the y-axis, and you will never know the representation of the x-axis. Like for instance, I'm going to show you something. For instance, an element x is defined as a z, where is known as what? The atomic number. And this one is known as what? The mass number. Now we have for oxygen, we have oxygen 18, oxygen 16, 8. So we are plotting a graph of what? Against what? So the x-axis already is known as what? The atomic number. Why the y-axis is known as what? The percentage composition. So we are plotting a graph of what? Percentage composition against atomic number. Are we there? So the y-axis represents the percentage composition, while the x-axis represents the atomic number.
So one not see your
You're not seeing my board?
picture.
Yes.
Picture.
Yes. Ask your question. Ask your question, Megan. There's no time.
So it's okay.
You have seen it. Is your doubt clarified?
I'm not seeing it.
So what did you want to ask?
There's a new
So I'm
comment on
not
YouTube.
I'm
Let me
not seeing
check.
your board, sir.
You are not seeing my board. Brittany, are you seeing my board?
See, I would not see but I've seen the camera.
Are you seeing it now? Ha!
The
Brittany.
picture.
Cha! You know I'm not even shaking this phone. Are you seeing it now?
So I'm not seeing.
They should go here.
Most of your colleagues on YouTube are commenting that truly it is really clear on YouTube. I don't know why you are not seeing it from here. Are you seeing
If you're
now?
concerned.
Are you seeing now?
So I'm saying,
Mm-hmm. Okay. Now, what part of the mass spectrometer ensures that the path traveled by the isotopy differ? What part of the mass spectrometer shows that the path traveled by the isotopy differs? We want to look at the part on a mass spectrometer that shows that isotopy differ when they travel. So what part? You need to first of all know the various parts of a mass spectrometer, because if you don't know it, then you will never know what they are doing. You will never know. You see, most of your colleagues, they are sending comments from YouTube. So I prefer if you go to YouTube, Megan. Have you seen the link?
so she's not online.
Okay, Brittany, have you seen the link for YouTube? Eh?
Let me check. Yes, let me check.
Because if you see the link on YouTube, then you'll see. Okay, I think all of my students have gone to a YouTube page. I think that's more better and more visible. So once more, I prefer using the YouTube channel. Just that this is your first time you are having a YouTube section channel. So for that reason, and most of you people going to YouTube, I really appreciate that. So for that reason, the link has been sent. Brittany, I think you can see the link. Good, 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 good. I love this comment. Yes, comment in the YouTube page. From there now, answer. Nobody should comment again my phone, please. Comment straight in the YouTube page. Don't comment again my phone. Thank you all for entrusting the YouTube page. I think it's more better there. Now let us get to more work. So where did I end? Let me open the PDF again so that we continue from where I ended. Fine. Now you people are going to enjoy the best class. So please be free to drop all your questions directly on the comment section. They'll attend to you immediately for clarifications of doubt. Are we together? While I'm opening the PDF, let me try and open the PDF. Good. So any question you want to ask, just ask one time and you see what is happening. You see how the answer will be addressed back to you immediately on the comment section. Please feel free to ask any question, because tomorrow might tell you might go tomorrow and see these questions that I'm asking, as well as you might not see them. I'm not assuring you anything. But if you see them and you know now like this that you did not ask a question, you have yourself to be blamed. If you don't see them and you ask a question and you understand, good and fine. So we are aiming for A grade, more success. Okay. So we ended somewhere. We ended in which question number? Where was that? Where did I end? Not seeing it though. I've opened a different PDF. Sorry for that interruption. I opened a different PDF. Please let me get the PDF. It happens. It's something natural. Don't bother. So let me get back to the PDF, please. Just give me a few times. Prof, did I send the PDF to you?
No, bro. I think
Okay, this
it was, yeah, you were in here. This is it.
Yes. Okay. Yes.
Okay.
Continue.
Okay.
Good. Okay, we ended under the spectrometer. So we are going to continue from there. Now that you are joining the YouTube channel page, we're going to continue from where we ended under the spectrometer. Now let us continue from there. So I already said we're plotting a graph for a brief representation of percentage composition against what? Atomic number. Secondly, I went down further to explain. The next question that followed was that you should tell us what is the position or that makes the difference in the atomic number in a mass spectrometer. And I said if you don't know the various parts of a mass spectrometer, then you will never answer that question correctly. So what are the various parts of a mass spectrometer? That's the first thing you're supposed to know. And since you don't know the various parts of the mass spectrometer, then you just know that all of what you'll be answering there will be wrong. Good. The first thing I'm going to tell you, what actually causes it to differ from each another is because of the magnetic field appliances. So when you tell us that that is due to the magnetic field appliances, that is, we are saying that F is equal to B QV, the magnetic field appliances. Now, what do you understand by magnetic field appliances? Most of you people just go and sit down and you don't even know. Another way of answering the part that differ, we talk of what? Deflection and analyzer tube with magnetic field. So we can talk because of the magnetic field appliances, or because of what? The deflection and analyzer tube with magnetic field. So you can also talk of what? Deflection with magnetic field. So that is what actually differs for the various parts in the mass spectrum. That's how you answer that question. I've given you what you say for the question. Now the next part of the question goes like this. We look at the next part of the question. The next part of the question says, what excess temperature of Prof, please read it from there. I'm not saying it. Is it hydrate carbonate? What excess temperature?
What question?
Question D, under the graph of the spectrometer. Yes, that's it. Okay, question D.
What excess lumps is that D?
Okay. What excess
lumps of barium
carbonate
are added to dilute hydrochloric acid?
Yes.
The following reaction takes place.
We
have barium carbonate plus,
okay, Prof, please, if possible, send the question to the students in the WhatsApp page. Then please download the PDF in the WhatsApp page so that you follow as we are about to answer. Okay. So now and the equation is as follows. We say barium carbonate plus 2 hydrochloric give barium chloride. Chloride is 2 plus water plus carbon dioxide. Now, let us send the question to the group. Then you'll see what we want to do. Please download the questions in the maths group. Prof is about sending the questions to the maths group.
There's going to be a challenge. They will not be able to use the question and YouTube at the same time.
Okay, they will not be able to use it at the same time.
Yes, we'll be forced to read.
Okay, so we're going to continue reading. But without no restanding. Let me send it. There's some of them that they might have. They might have two phones. Yes, no one can tell. Stupid. I'm telling you, the thing is, it's still important for us to send it because Reading like that and going, we are facing challenges.
A lot, yeah.
We have to go very faster. So let me send the question so that we'll go faster than this. Then you will see what awaits you tomorrow. Okay, PDF. Where's my PDF? Documents. Downloads. Browse document. Okay. Good. I've just sent it to you. So people are receiving the question. The question will soon be with you in a gist fit. Why I proceed with what I was answering. So the question has been given: barium carbonate plus that 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 equals to that. Okay, now they say two experiments were carried out on the following. The rate of their reactions, they, Prof, please read it from there.
Let me get the
Were plotted as follows. Okay,
carried out to follow the rate of this reaction. The results were plotted as follows: experiment 1 and 2.
so okay, if you look at the PDF that have come, you are going to be seeing the graph for those that have it there. Now the next question says, yes, go ahead, Prof.
Okay.
Yes, just be going ahead, Prof.
What would have been plotted on the axis in experiment 1 and 2? Experiment 1 and experiment 2. Let me quickly put the graph here.
Okay, Prof will quickly put the graph on the board. So now we'll look at what we'll be plotting on the various axes. And please take note, these questions are one of its kind. A, B, A, B.
That's all. This
Good.
is experiment 1.
So when I look at experiment 1 and I look at experiment 2, what we plotted on those axes? Both experiment 1 and experiment 2 are the same thing. The first one is talking of what? A decay graph, and the first one is talking about what? Still a decay graph. But now, this one is talking of is decaying, and this one is decaying. When you see this thing in chemistry, what comes in your mind first of all? It should be what? Time constant, the half-life of every particle. So now when I look at this thing in experiment 1 and in experiment 2, we are just simply plotting what? The volume of carbon dioxide versus time. That is the volume of carbon dioxide against time. So A is given to us as the volume of CO2 against time. So we are plotting a graph of the volume of CO2 against time. When you look at this thing, it's simply the graph of carbon dioxide against time. Both experiment 1 and experiment 2. This is what we are plotting. Now, read the next part, Prof.
Okay. We have Roman to state with a reason what would happen to the total volume of carbonate given off if powder barium carbonate were used.
Okay, state with a reason what will happen to the total volume of barium carbonate given up if powder barium carbonate was to be used. Now they are telling us that what will happen to this barium carbonate if its total volume was given up. If actually we're supposed to use the powder one, that is, I've taken this substance and I've ground it into powder, what will happen to the total volume if it was given up? That is what we want now to understand with a reason.
They have not received a question.
They have not received the question? Okay, let me resend the question. So, Prof, you verify for me if it has come so that I can continue the class. Okay, Prof. I think by now the question should be there.
Yes.
The question is there, right?
Uh-huh.
Good. So I believe for those, please, I believe it's not, this question is mainly for those that are signed. Let me say it like that, because they are the ones that we're actually in direct contact with presently. For those that are joining the YouTube page, please just endeavor
We'll just be
to
reading for them.
follow
So
for us
just
as
be
Prof read through, so that you follow directly. Good. So Prof, we're somewhere.
Yes.
So we had to state with a reason. Is that it?
Yes.
What happens when the total volume of
If if the powdered barium was used, state with a reason what will happen to the total volume of carbonate given of if powdered barium carbonate were used.
Carbonate given of if
Powdered
powder barium
carbonate
carbonate
was
was used. Don't forget first of all that carbonate is already a gas and it has to be released into the atmosphere. That is how you start reasoning things. So what will happen to that volume of that gas when we use the powder one if everything was used? In other words, I simply tell that what happens to a gas when you use, for instance, or let me take for instance juice. When you use all the quantity of juice you have in a container, imagine you shake, you open, you shake, you open in various time interval. What will happen to that gas? That gas will simply evaporate in space. But now we are interested with the volume of the gas. We are no longer interested with the state of that gas, because we know that all the calcium carbonate will be given out now. Now from our equation, what do we notice? You notice that barium carbonate plus hydrochloric acid give you barium chloride, which is a salt which stays, and water. Meaning that this is what? This is an aqueous solution plus carbon dioxide, which is a gas that sends it out. It means that we are simply talking about the total volume of carbon dioxide interpretation in this question. Most of you people will go and be explaining concerning the total volume of carbonate, but we are instead talking about what? The total volume of carbon dioxide. So there we go now. We are now going on to say the total volume of carbon dioxide will remain the same. Reason being that the total volume depends only on the moles of barium carbonate. What did I say? The total volume of carbon dioxide remains the same. Reason being that what? Reason being that the total volume depends on the moles of barium carbonate used. Reason being that the total volume depends on the moles of barium carbonate used, because the blah 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 of the moles of barium carbonate was used. Because the total, let me put it down because people are funny, volume of barium carbonate was used. Now we proceed. Another thing is that powder do increase what? The surface area. Why do we say powder do increase the surface area? Powder do increase surface area, thereby leaving what? The final volume unchanged. That's another way of putting it. You don't want to tell us that the total volume of carbon dioxide remains the same because the total volume of barium carbonate was used. You tell us that powder increased the rate of surface area, thereby leaving the final volume unchanged. Prof, highlight the next question.
Okay. Roman 3. When the experiment is performed at a higher temperature, will the rate of collision increase or decrease? Explain.
Okay. at a higher temperature, will the rate of collision increase or decrease? Perfect. Now, one thing you need to know is that what? First of all, and first foremost, we understand what that the kinetic energy is directly proportional to the temperature. Never you forget this. The kinetic energy is directly proportional to the temperature. And from this thing, I'm not even supposed to explain anything again. Because when we talk of direct proportionality, depending on what I taught the off-site students in class, you understand that a direct proportionality simply means anything that is happening to my brother must happen to me. Anything that is happening to me must happen to my brother. We are tied to one. If I am increasing, he is increasing. If I am decreasing, he is decreasing. But now, by saying that, I believe that our on-site students too have actually gotten the concept of direct proportionality. Good. I'm now going to talk. The rate of collision increases, reason being that the kinetic energy is directly proportional to the temperature. Molecules move faster, more frequency collision, and a higher fraction with a faster rate. So what are we saying? We are saying that the rate of collision increases, reason being that the kinetic energy is directly proportional to temperature. What is kinetic energy? The energy of moving particle, the energy of motion. So what are we saying? The molecules move faster, they collide faster, thereby increasing the temperature. So an increase in kinetic energy will lead to what? An increase in temperature due to the what? To the quick movement of molecules. Full stop. Prof, highlight the next one.
State-Henson's law.
The next one talks of State-Henson's law. This is a technical question that has to do with what? Thermochemistry. If you have studied your thermochemistry very well, you understand what the Henson's law states. So what is Henson's law saying? Henson's law states that the total enthalpy change of a reaction is independent of the road taken, provided the initial and final conditions are the same or kept constant. So what are we saying about Henson's law? Probably let me highlight a little bit on Henson's law. It's a very crucial question.
And it's always there.
And it's always there. You must take the law. So we are saying that A to B to C. Oh, I think you can remember this, right?
Mr. Bansi.
Mr. Bansi Bernard. Well, I don't need to put the enthalpy. All of those things are needless, though. My problem is about the law. So I want you to understand the law. So what is Henson's law saying? That the total enthalpy change of a reaction, the total enthalpy change of a reaction is independent of the road taken, provided the initial and final conditions are kept constant. As simple as that. Meaning that what? For me to leave from a product of A to a product of C, it doesn't care if I pass from B or I pass from D or I pass from K. No. It is independent of the road taken. Meaning that if I want to produce savon, a typical example is an example of savon, sapronification. Everybody has his own method of producing savon. Independent of the road taken, the end product is what we want. That is simply Henson's law. So anytime you think of Henson's law, think of all the method for the guys. You think of all the method you take to chat a girl. When the girl tell you no, because you will say, even if you tell me no, I will not give up. So you are independent of any road taken, provided the initial and final conditions are kept constant. Meaning, if the girl continues saying no, you keep using what? Indirect roads. Are we together? So you go ahead with that. Now, that was Henson's law. I think with this explanation, anybody can state Henson's law in the exam. And never confuse Henson's law with Raoult's law. Those are very two technical questions. Good. Proceed to the next one.
What is thermometric titration?
What is thermometric titration? Now let us listen to what is thermometric titration. That's simply asking you what? What is titration in relative to temperature? That is the question interpretation. You know what is titration. You have been doing it in the lab. You know what is thermometry. You have been doing it and studying it. Thermometry is just simply the science that studies what? temperature and its property. Now they want you to define titration relating it to thermometry. So we are going to say titration where temperature changes is monitored by an instant pH or color change. That is thermometry titration. A titration where the temperature changes monitored by an instant pH or color change. That word temperature must be very important in it. Monitored by a constant or an instant pH or color change. Good.
Give thermochemical equation to represent the following processes.
Good.
For magnesium or chlorine, first is combustion,
Good.
then atomization, hydration, and lattice energy.
Good. The first one, this is just simply a way where they used to ask you to do the combustion stuff and everything. You come out with that diagram. People know the Born-Haber cycle. Look at the way they have asked the Born-Haber cycle this year. They have not just asked you to draw the Born-Haber cycle in this particular question that I have sent, because we have already noticed that students are familiar with when they say draw the Born-Haber cycle. Hey, prof,
I'm telling you.
crown work is working. Crown work is working. Now let us understand actually how the Born-Haber cycle functions. Good. Let us look at what the Born-Haber cycle says in each of the individual steps that they are asking us. So we give only the individual steps that they are asking us. The first one is combustion. When you hear of combustion, what comes into your mind? Oxygen, please. Oxygen, that is the first thing. Magnesium have just simply reacted with oxygen to give us what? Magnesium oxide. That is the first thing that should come to your mind when you hear of combustion. So I'm going to look at the enthalpy change of combustion. That is H of enthalpy change is equals to what? Enthalpy change of combustion. This is how they represent it. Now, what do I say? For combustion, very funny. What comes in my mind is oxygen. So if I want to write the enthalpy change of combustion, what do I do? That is magnesium. What is the state of magnesium? What is the physical state of magnesium? If you do not know the physical state of any compound, then you will never know what that compound is forming. First of all, the physical state of magnesium is a solid plus oxygen. Oxygen is what? 2. And what is the physical state of oxygen? Gas. To give you what? Magnesium oxide. And magnesium oxide now is what? A solid. A solid that is combined with a gas remains a solid. A solid that is combined with a liquid becomes an aqueous solution. So be careful. We are going together. So this is the enthalpy change of combustion. So I can put here H delta H subscript C, enthalpy change of combustion. But now when I look at this equation, it's not balanced.
Okay, someone said in the comment already.
Okay, someone said in the comment that the equation is not balanced.
It's not balanced.
Thank you for that. Now we are about to answer your question. So now let us balance this equation. 2 oxygen, 1 oxygen. 1 magnesium, 1 magnesium. When you look at the states of magnesium and the oxidation numbers of magnesium, definitely magnesium does not need anything of 2. But there is a problem with oxygen. This is where we introduce what we call the half balancing chemical equation. Don't be surprised that you balance chemical equation using fractions. I don't know if this year actually such things can come. So what is happening now is that I'll introduce a half here. This half simply means I have balanced the number of oxygen related to magnesium oxide, and the equation has been balanced. Now, 1 magnesium, 1 magnesium, 1 oxygen, 1 oxygen. Are we there? Good. Now, we now proceed to the next one, which talks of what? Atomization. Atomization. How do we write the enthalpy change of atomization? I'm going to show you. That is delta H is equals to delta H A small t. That is atomization. Now, when we talk of enthalpy change of atomization, we are simply talking of what? conversion of different matter states. We are simply talking of what? Conversion of different matter state. How do we convert from this state to another without interaction? Now, the original state of what? Magnesium is solid. Atomization, what should come in your mind anytime you hear atomization is what? Gaseous state. As I'm saying all of these things like this, tomorrow you will go and see Joe the Bonhaba cycle, and you will go and be doing your own thing.
It's today.
Today, we are already in the next day, you go and be doing your own thing. This is it already that we are drawing, but giving it step by step. Please, we are already giving it step by step. And I'm already explaining, when you hear combustion, what comes in your mind? Oxygen, the addition of oxygen or the subtraction of oxygen. That's why we talk about what? Redox, reduction, addition. Combustion, we are adding oxygen. Oxygen must be present. Oxygen is burning. Atomization, we are living from one physical state to another. And any state that lives from one state to another to undergo atomization must live directly from a state to a gaseous state. Anything that wants to undergo atomization must live directly from a state to a gaseous state. And that is why you cannot take a gaseous state to a gaseous state and call it atomization. It must leave another state to a gaseous state. It can leave liquid to gaseous, it can leave solid to gaseous, it can leave aqueous to gaseous. That is the atomization. Good. So we are living from a solid state to the gaseous state of magnesium. So this will give us, this is what we have, solid, to give us what? Mg gas. Magnesium gas, and that is the atomization energy, enthalpy change of atomization. So here is delta H subscript T. The next one was hydration. Now, hydration. What do you hear by hydration? I think the biology students are already familiar with the word hydration, that even if a biology student has to answer a question under hydration and that student fails, me myself, I will kill you. I will kill you. Because hydration simply means the addition of water molecule. That's hydration. Addition of molecule. You want to hydrate something, you want something to be hydrated. That thing must soak water. That's just a layman's language. So let us look at hydration. We proceed. Enthalpy change of hydration is denoted delta H, that's the enthalpy change, equals to delta H small d. That's how we denote the enthalpy change of hydration. And what are we saying? We are living from a gaseous state, not just a gaseous state, but a gaseous balanced atom. What is a balanced atom in this case? I'm talking of a stable atom. What is a stable atom? When you are in this class, you should already understand what a stable atom is. A stable atom has to do with the orbital shares of those atoms. The first one, an atom that has two shares on the last outermost share, is always known as a stable atom, but it is partially stable. When you have four, you're still stable, but you are partially stable. Most of you probably are still going to see this thing in the inorganic part of chemistry. It has just come somehow now under this thing, but you don't still understand. Now, when you have 8, then we are talking of what? A complete filled orbital, which is what? Completely stable. This is where we talk of stability, a full stability, partially stable, stable. This one is stable, partially stable, completely stable, which you are going to be seeing them when you'll be doing the inorganic part. So now, what is hydration? I say you are leaving a gaseous state, you are adding a gaseous state, a stable atom gaseous state. Let me use the word. A stable atom gaseous state plus an aqueous solution, because an aqueous solution is already an hydrated solution. And that aqueous solution could be water or H+, the way we always represent it. in this case. So what am I saying? For magnesium to become stable, what does magnesium need to do? Magnesium now you are going down to what? Electronic configuration. If I ask you people, most of you people now to write the electronic configuration of magnesium, some of you will be telling me 2:8 is to this is to this. Hey, prof.
Yes.
Some of you people will be saying 2 is to this is to this. Meanwhile, we don't mark that one again advanced level. We don't know again 2 is to this is to 8 is to 8 is to 2 is to 1 is to 7 is to this. We don't know that again. But normally looking at magnesium fall under what? Group 2 element. So it has a 2 on field element on the last outermost shell. So I don't even need to be going far to be asking myself of the electronic configuration. So all what I just need is that I know that magnesium must lose 2 electrons to become completely stable. Completely stable. So if magnesium lost 2 electrons in the gaseous state to become completely stable, what do I now do? I add an aqueous solution to cause dehydration. So I'm adding an aqueous solution to magnesium, and that aqueous solution, like I said, could be water. So I can put H plus O, I put H2O, let's just put water now, and I'm going to still have what? Magnesium in a gaseous state plus water. Some of you people say, why is it that it has not mixed to form a compound? How can you add a gas to a liquid? Okay, I know that's what some of you people are having in mind. How can you add a gas to a liquid and expect mixture? Definitely the gas will still evaporate as it enters the water now. If you introduce gas into water, the gas will still evaporate the way it enter water. So that is why we still have this, and that is what we call hydration. Yes, the gas is in liquid, the gas is a hydrated gas. So once we open the gas in liquid, it leaves. A typical example is your bottle of juice. Once you buy juice and you open it, the first thing that happens is that gas evaporates, but the gas is in liquid. At that point in time, we call it hydrated gas, but they are not mixed. Please, any man in your own direction. That's why once you open it, it leaves the bottle. Bam! Good. We proceed to the next part. I'm taking my time to explain this thing because it's already the Born-Haber cycle. If you just take this time, start putting arrow, when you reach lattice energy, you send it back up. You have already joined the Born-Haber cycle. Just putting arrows and going down, that's the Born-Haber cycle. That's why I'm taking my time to explain this thing. Now we'll go into lattice energy. Now, when you hear of lattice energy, what should come into your mind? That is where most of you people now you'll be looking at me. Lattice energy simply means the compound was formed. In this case, it simply means the compound was formed through what? Fusion. Now let us see how the compound is being formed through fusion. We are already attained hydration. The next stage after hydration is lattice energy. What did we have when we had left the hydrated state? Lattice energy. Fission. What did we have when we had lattice energy? That was magnesium gas in a stable state plus what? Now oxygen. See, oxygen now, in this case, oxygen now is supposed to become stable too. And we know that oxygen too is going to do what? Gain 2 electrons because what? It's having 6 electrons at the outermost shell, and for it to become stable, it must easily gain 2 electrons rather than giving out 6 electrons. So for oxygen to gain 2 electrons, it becomes 2 negative. And what happens? It means that what? It has lost the atom because this 2 under here represents the number of atoms. When it comes to negative now to give you what? Magnesium oxide. Oxygen is in a gaseous state too. And then now this is what? The fusion of two gaseous states to give you what? A solid. That is what? Through what? Through an energy called lattice energy. Now every time to be defining it. Read your book to define lattice energy, and lattice energy is defined as delta H L T T. Prof,
Yes,
can
Prof.
go to our next question.
Okay. Yeah, we are there. We are on question 2 now. What is a phase diagram? Prof.
What is a phase diagram?
Okay.
That's why the class was supposed to have started by 9 to stop by 12.
When you are tired, give me both. Let me help you, and then you continue.
Okay. Good. That's why I was supposed to start by 9 and stop by 12. This is my Obanje on
Prof, I
offside.
think you should reduce the rate and we should explain deeply. If not, you will finish by the time they will be finishing paper 1.
I'm telling you. Okay, let us look at what is a phase diagram. Good. What is a phase diagram? Most of you people just sit there, you don't even know what is a phase diagram. If I ask in the comment section, most of you people will not say. Okay,
let's speed up, because I believe by now a student have to know many things.
Okay.
So it means there are a lot of abnormal students here really.
Okay, thank you for that. For that reason, I'm going to speed up, my boy. I believe most of us, we are familiar with what we are about to do. Good. So we are speeding up. Phase difference diagram simply is a diagram that shows the physical state of a substance as a function of temperature and pressure. That's just it. A diagram that shows the physical state of a substance as a function of temperature and pressure. Now, another way we define phase diagram is that what? It's just simply what? Boundaries that shows the conditions where two phases are in equilibrium. The boundary that shows the condition where two phases are in equilibrium. That is all about it. Now, let us look at those type of things. They say what? Next question talks about what, Prof? We are speeding up now like this. No time to waste.
Okay, we have the question says, what is a phase diagram? Then next, sketch a phase diagram for the variation of vapor pressure with composition
of ethanol plus water
mixture.
Good. So I don't even need to I will not sketch anything as we are going very faster. Ethanol plus water shows a positive deviation from Raoult's law. You know the diagram. Once I say it shows a positive deviation from Raoult's law, you already know the diagram with a minimum boiling point. That's just it.
Tropic mixture.
Yeah, that good. Thank you, Prof. Azeotropic mixture. Good. Let's go to the next one.
Okay. What is happening here? Okay, the next question says, what type of phase diagram is represented in Roman 2 above azeotropic? We have spoken about that already.
Yes.
Positive deviation from Raoult's law.
Good.
So state Raoult's law. That's the next part of the question.
Good. The next part of the question says
stating Raoult's law now.
State Raoult's law. So let us
that
look
one
at
is very clear.
We can state Raoult's law. So I'm going to say Pi is equals to Xi Pi. Let me not use I because it's funny.
Let me already give the wording of the Raoult's law. It states that
P is equals to
the partial vapor pressure of each component in an ideal liquid mixture is equal to the vapor pressure of the pure component multiplied by its mole fraction in the mixture.
Good.
That's Raoult's law.
The partial pressure of an ideal mixture is equals to what? Or directly proportional to what? Directly proportional to its mole pressure, to its mole fraction.
Yes, multiplied by the pure pressure.
By the pure pressure. So the partial pressure in an ideal solution is directly proportional to its mole fraction, to its mole ratio multiplied by its pure pressure. That is just Raoult law, and that is it that I've put on the board.
When
like I said,
is a mixture
don't
of two
confuse.
miscible liquids said to be ideal?
When is a mixture of two miscible
liquid
liquids said to be ideal? One, the intermolecular force between the two liquids do what?
They are alike.
Are the same. Are we together? The intermolecular forces between the two liquids are the same. Two, the enthalpy change of the liquid is equals to what? 0. The enthalpy change of the liquid is equals to 0. What other condition again? We can also talk about what? Their volume mixture is equal to 0, according to Raoult's law. Their volume mixture will be 0.
The next question would say, give an example of a liquid that is miscible with hexane.
With hexane. Good. Hexane is something that you look at it like that, you will never understand. You'll be asking yourself, what is hexane? You have seen in organic compound. And we know that there is really no difference between hexane when we talk of what? We are talking of cyclobenzene, we are talking of benzene, and we are also talking of what? We are also
Toluene.
talking what, Prof?
Toluene.
Yes.
Toluene.
Toluene. We are also talking of toluene. So what are the types of mixture that actually mixes with benzene? This is now something that you should already know. What are the type of things that will mix with benzene? We first of all know that these are non-polar dissolvants. So what types of liquid will mix with them? I don't even need to be saying it again. Tetrachloride, carbon tetrachloride. That's an example of a liquid that can be mixed with them. Another one, Prof.
We are talking about what can mix with hexane. Benzene can.
Exactly.
Benzene can, and even cyclohexane can as well. Next question says, consider the equilibrium reaction. We have that. And then, what happens to the equilibrium constant M when the reaction is reversed?
When the reaction is reversed, we already know what will happen now. We already know that normally, I don't even need to be going. Kc is equals to what? The product of the this thing raised to the tautomeric coefficient divided by their this thing and so on. So we already know we are not interested in that, because that tells us that when it is reversed. So when it is reversed, I'll say let the reverse one be called what? Kc prime. Are we together? When any formula is being reversed, we are simply talking about what? The inverse of that formula. So Kc prime will now be equals to 1 over Kc. Are we together? So which is just simply equals to what? 1 over M. From here now I can explain anything I want to explain. So that's a reaction when it is being reversed. It becomes what? The inverse of the reaction. Continue, Prof.
Okay, the moles of the reactants and products are halved. So the question is, what happens to the equilibrium mixture, the equilibrium constant M, when the moles of the reactants and products are halved?
Okay, what will now happen to the equilibrium constant M when the moles of the reactant and pressure are halved? It is very simple. It will remain unchanged. Nothing is happening to it. It will remain unchanged. You can see very well that it is the ratio for the reactant is 2:1. For the product is what? Is 2:0. So we have what? It remains unchanged.
What will be the effect on the equilibrium constant? On the equilibrium position when pressure is doubled?
When pressure is doubled, now that's when now you are supposed to be looking at something. Look at the reactants. We have 3 moles. Am I wrong, Prof?
Yeah,
3 moles of gases.
True. Yes,
that's 1, 2, 3 moles of gases. You look at it again. We have on the product, we have 2 moles of gases on the product.
Yes.
Is that it, Prof?
Yes.
2 moles of gases on the product. So be looking at your own, and you are going to be seeing what I'm talking about. You have the 3 moles of gases, 2 moles of gases on the product. Now at a higher pressure, yes.
The equation.
Let's Prof just quickly put the equation down. The duster is on the table there. So at a higher pressure, like I was saying, Two SO3. Good. That's our equation on the board.
Then Kc here.
Is equal to M. That's our equation on the board. So what am I saying? I'm saying that at a higher pressure, what happens to the equilibrium position is shifts where there are fewer molecules. At a lower pressure, the equilibrium position is shift where there are more molecules. So what are we trying to say is that what the equilibrium position shifts to the right, because at the right, what happens there? There are fewer moles. So at the higher temperature, the equilibrium position shifts to the right. Prof, next one.
State Hess's law. I think that's the question. Sorry, state Lewis theory.
State Lewis theory of acid base. That just simply asking you to define acid and base reaction in terms of Lewis. According to Lewis, this thing is something that is coming every year. We are still going to see it this year. So let us define it in terms of Lewis. Lewis define an acid as what? An electron pair acceptor base. Why an electron pair acceptor? Why he define a base as what? An electron pair donor. That's just it. Next one.
Yes. All right. We are closer to the end of this part. This part here. The next question says, which of the following is solely Lewis acid-base reaction?
Base equation. Which of the following is solely Lewis acid-base equation? And we have what on the Prof? Look
we
at
have X and Y. So we have ammonia.
Okay, in the equation of X, we have ammonia plus what?
Let me quickly put that on the board.
Yes, put it down on the board.
Ammonia. Let's see. Ammonium ion. And water. Then this is X. Down here we have ammonia. Ammonia and copper. Okay. These are the two equations.
Okay, we have our two equations.
Which of them is solely Lewis acid-base reaction?
Good. When they talk of solely, please, when they talk of solely, they are simply telling you that solely simply means only or exclusively. Hey, Prof?
Yeah.
Solely simply means only or exclusively. So, which one is only Lewis theory, or which one is exclusively Lewis theory?
Meaning which one is exclusively an electron donor and acceptor
pair. Exactly. So we have what? We have the X. Look at the X very well. Look at the X very well. People should observe the X very well. Also observe the Y very well. And there's a trick on the question. Both of them are donating.
There's the worry. So the definition of acid and base you gave is for Bronsted and Lowry. Who is asking that? Okay.
Bronsted and Lowry.
Yes.
No, I don't think so. There's something. Bronsted and Lowry too. He explains explained by Lewis theory, right? Then the Bronsted and Lowry's theory. You understand something now? So the Bronsted and Lowry's theory, they define acid and base as the same thing, because Lewis acid and base define as what? Acid is equals to electron per acceptor. Are we together? While base is electron per donor. No H plus needed. That was the only difference in their definition.
Yes, the thing
He
is
excluded
the
H plus.
person is surely missing out something little.
Yes.
Bronsted and Lowry defined the
Good.
acid and base with respect to the proton. We have the
proton
proton
donor and the
proton
non-acceptor.
But
Lewis
is electron donor and electron acceptor. That's the main difference.
That's the main difference. So he was talking of proton donor
and proton
acceptor. But Lewis was talking about what? The electron.
Yes.
Please do not be confused. That's why I said the theory actually, the Bronson's theory actually goes in, but the Lewis theory actually explains to the Bronson's theory. Because when he talks of electron, what are the combination of an electron? You already know where you are going to.
Exactly. And so we can say from Bronsted and Lowry principle, an acid is a proton donor.
Good.
And a base is a proton acceptor.
Good.
Then for Lewis, now we can say acid is an electron pair acceptor, and a base is an electron pair donor. So that is it for Bronsted and Lowry. And then, okay, understood.
That is
so
good.
People can put comments in the can put questions in the comment section so that we can be quicker. I think. Prof,
yes.
The next question.
Yes, the next question.
Let me.
So learn to put questions in the comment section.
What is a strong base? Give an example. So we have to define a strong base and give an example.
Good. What is a strong base and give an example. Some of you people will say, what is a strong base? You will carry yourself. You don't even know what is a strong base. Now we are there. What is a strong base and give an example. We have defined a base according to Lewis. Now we want to know what is a strong base. Should I say we're defining such things? I don't think it's necessary now, Prof. Just proceed now.
We can proceed. This is not strange to any student. What is very important is the calculation we have below. So now, okay, determine the pH of a solution of 0.10 mole per dm cube of phosphoric acid of formula H3PO4.
Good.
Yes. A solution of 0.
Prof, read it again for them to listen to it well.
Okay. The question says, calculate a pH. What is the pH of 0.1 mole per dm cube? I think that's it.
Yes.
The pH of 0.10 mole per dm cube.
Good.
Of what's it? Phosphoric
acid. H3PO2.
PO4.
No, PO4. Thank you. Yes, PO4.
Voila. So that's it. Calculate. Find the pH. pH is. Prof. Should I?
Yes.
Okay. We have pH negative log to the base 10.
Yes.
Of the concentration of H plus.
Exactly.
Yes. So now what human beings are supposed to do here is we have H3. Oh, how are you using this one? I'm not writing.
Take this one.
Okay.
And you use your close and turn it under.
Okay, we have H3PO4, and we can start by we need a concentration of hydrogen plus. That's hydrogen ion.
That's it.
So from here we can have H plus and PO4 minus. We just need to balance this. So H plus will just come here and put 3 and it is balanced. So what does it mean? 1 mole of the phosphoric how do they call this?
Phosphoric acid.
Phosphoric acid, thank you, Prof. So 1 mole of phosphoric acid will yield us 3 moles of H plus. So what does it mean? It now tells us that 0.10 mole of phosphoric acid will now yield us X. So what will X become? x is going to be 0.10 times 3, of course. So that would be 0.30. Now, this is the concentration of H plus. And then we are going to find negative log to the base 10 of this concentration, which is 0.03, sorry, 0.30. I don't have a calculator, so
Let me see.
you can do calculations at your ends.
Yes, you just do the negative log of that.
Negative log of this, and the value gives.
It should be
There was one
roughly-
very good calculator around here.
The negative log goes up. It should be roughly 1.56.
Okay.
1.5.
Let's take that.
Just take 1.57.
1.57.
Yes.
Seven.
Somebody can do it and drop in the comment section.
And
Please.
then when you do this calculation, it's very good to make a small check. We said this is phosphoric acid, and if you calculate and then you have a pH above 7, just know that you are filled, because acids do not have pH above 7.
Yes.
Okay, next question. Okay, so the next question will say that a solution of 0.01
This one is coming tomorrow.
mole per dm cube of benzoic acid of Ka this. So we are also to determine the pH, Prof.
Good. So we are supposed to determine the pH of that one. And now in this case, I've given you the Ka. So following what Prof did on the board, you are still supposed to come out with what? An equation. And you already know what we need to do to have that equation. So right now I'm going to handle this. And this question is coming tomorrow. Take note. Let me talk like that. The online people should online cybercrime.
I hope those who are in Moliko are not hearing us
The
here.
online cybercrime should hold me.
Because
After saying that this question will come tomorrow, they say that's I'm leading students. So like I'm saying, this question might repeat itself. It looked like a question I wrote in my ear. So what am I saying here? Like Prof said, benzenoic acid is a carboxylic compound. So what does it do? The reaction must be reversible with H plus what? What has happened? Negative. Now, we are looking for what? The concentration of the hydrogen ion, like he said. Are we together? And now I want to have the concentration of hydrogen. So how many moles of hydrogen are here? From the other equation he had 3 times the H plus, which gives you what? 3 moles of hydrogen. In this case, how many moles of hydrogen are here? 1 mole of hydrogen. So now what do I proceed with this 1 mole of hydrogen, which is just equivalent now to what? So now the concentration of this now will give me what? 0.01 mole per dm cube of hydrogen. Now, concentration of hydrogen plus now will be equals to what? The square root of Ka dot the concentration of the 1 mole of hydrogen. We already have 8 Kh. So this is now equals to the concentration of hydrogen in this case now will be equals to what? 1 point, Kh is given to us as 6.0 times 10 to the negative 5 times 0.01. All these square root. So if you do this thing very well and take the square root, that's 6. 6 times this, that's 1 on 100. So what is happening? We have gone to 600. Square root of 600 is around 36 is 6. So 60, 6, 6, 12, 7. So we are around 7 point something. So this 0.75 times 10 to the, it's negative. What did I do? I sent this one to 100. As did, I multiply 1 time 60 like I do. So the other one affected here, so it should give -4. I don't know. Can somebody drop it for us in the comment section? Do the square root of 6.0 times 10 to the negative 5 times 0.01. I think you can drop it for us there in the comment section for us
That
to be
one is
sure.
now arithmetic.
That is arithmetic. Please just drop it for us. Our calculator is back.
Someone is saying the question you sent in the group is not opening for me at the level of PDF.
I will
Just
send
continue
it.
here.
Just continue. I will send it for you in the Word version. For that, I will send the question for you in the Word version. Once we are done, you will receive a Word version. So this is the concentration of hydrogen ion, like the way it calculated, and which now brings us now to the formula pH, which is equals to what? The negative log of the concentration of hydrogen ion, which is now equals to the negative log of 7.75 times 10 to the minus 4. Like we said, somebody could check this answer and drop in the comment section because that's already arithmetic. So what is now the negative log of this thing? Log of base 10, the way we did for the other one. Same calculation.
And you insert this value here. Next question, because
Yes.
we cannot.
Once you insert the
Our
value there,
calculator here is not
it's
good.
not good.
We are not writing with you people.
It should be around, the pH here should be around 3.31. I don't know. 3.31 or 12. Somebody should check, drop in the comment section. We don't have calculator, we don't have time for that. Now, the next question says, what is a covalent bond? I'm not supposed to be defining this kind of thing.
Covalent bond.
Two atoms sharing pairs of electrons. Those pairs of
can
electrons to become
Define
stable.
it as the electrostatic force of attraction
Attraction.
holding at between the shared pair of electron and the of the bonding atoms.
Good. To become stable. Bam. Next one. The next question here says that what? Select from the element sulfur, nitrogen, oxygen, hydrogen, copper, two elements that will form a compound or form involving at least a dative covalent bond. This is easy. If you have studied your organic chemistry where you are supposed to be writing this thing without no problem. If you take nitrogen and hydrogen, definitely you have what you want because there will be a dative covalent bond in it. There will be a covalent bond in it. There will also be, in fact, nitrogen and hydrogen. You already know what I'm talking about. When you see nitrogen and hydrogen, we are talking of what? Ammonium. So let us look at it. We are talking of what? Ammonium. And if you draw the shape of ammonium, native covalent bond and a covalent bond in it. Good. So we'll just take hydrogen and nitrogen and hydrogen. That's just it. So nitrogen plus hydrogen will give you what? Will give you NH4. Are we together? So I have plus Na4 positive. This one now is the same as what? NH4 plus hydrogen plus should give you what? NH4 all this plus. Oh, this one is 3. One pair of electrons. I've already explained everything. And prof.
Yes, prof.
Yes. Next
Move
question,
on.
prof. What do you say?
I hope you are not sending me to the board.
No.
Select.
I'm sending you to the board.
Select. Who are we?
We are on what is a crystal.
You already explained this on the crystal lattice during Born-Haber cycle. Give 3 types of crystal lattice.
Give 3 types of crystal lattice.
Explain which of the crystal which of the 3 crystal lattices has loose
spacing.
I'm going to start directly with organic chemistry. Prof explained these things already.
If you were following up, you notice that all of the lattice were already explained. You already know the different form of lattice energy. So go and just check what is a crystal. Give the 3 types of crystal lattice. Then you also go and check which of the 3 crystal lattice has a loose spacing. Which of the 3, meaning that they want 1, they don't want 3. Because you parallel are funny.
Prof, where did you have the question? I needed. Okay.
Okay, have you seen it?
No.
Document.
Oh, whether it was there.
It's the other phone. Check the other
Let
phone.
me see.
Go straight to inorganic. Okay, while Prof is checking the PDF, let me read the PDF directly from the machine while he's checking. Some elements of period 2 and 3 of the periodic uh, table are lithium, carbon, fluorine, sodium, aluminium, magnesium, and silicon. State the properties that can be used to put the element into different group. This thing you don't even need to think twice, please. You know that what does the last element represent on an electron share? That is the question you should ask yourself. What does the last electron represent on an element, on the last outermost share? That is how you will know. That is one property in way they can put those things. I'm saying it like that because I don't want to give the answer. I want people to give me in the comment section. Please, for those that are following, tell me, how do we call, what is that last element? How do we identify that last element at the last shape like that? If it is 1, what does it represent? If it is 2, what does it represent and what it explains? You are going to have the answer. State the property that can be used to put this element into different groups. 1. I've already given the answer. The last electrons on the outermost share. So you tell me, go and check. There's a name for it. I want to see it in the comment section. Thank you. Pair the elements into the different periods. Now they want you to pair the elements into the different periods. Groups and periods are two different things. We have periods, we have groups. Group 2 elements can be found in period 1 element 2. It is very possible. You just need to be careful. Pair the elements into the different period. This is a typical example of somebody that do understand the periodic table. And group 1, group 2, and group 3 elements should not be elements you should go in the periodic table and then you are scared of the periodic table, you don't know what to do. Okay, I think Prof have gotten the PDF, so
Yeah.
you continue from there.
Prof, you are strong. Let's say, okay. Now we're going to continue with inorganic chemistry. I didn't want to talk on crystal lattice because at the level of Born-Haber cycle, Prof had to talk on lattice energy. It's still the same. The only strange thing there is what the 3 type of lattice energy that is not from our mouth that you want to hear it today on the day of your exam. So now we're going to proceed with state a property. Okay, that question has already been answered. So we will just go down. That property is what? The number of electrons on the outermost shell, right? It gives you the group to which the element belongs on the periodic table. That's clear. Now, pair the elements into different periods.
The same thing across the group.
Yes. Pair the elements into different periods. Now you have the elements here. You have lithium, carbon, fluorine, sodium, and what? Aluminium. Okay. So, okay.
Let's follow up.
So we are pairing into different periods. This element occupies 2 periods on the periodic table. You have period 2 and period 3. Remember, when you are writing, if we're talking about groups, I'll use Roman numerals. These little things are very important in chemistry. Now, those in period 2, we have lithium. Lithium is in period 2. Carbon is in period 2. And then fluorine. Yes, then those in period 3, we have sodium. We have magnesium. We have aluminium
and
silicon. And that's all. We move on now to the next. And then, how do you know elements on the same period on the periodic table? The number of shells tells you the number of periods. Exactly. Now, in the periodic table, why are lithium and magnesium diagonally placed? This question keeps coming all the time.
Every year, you will still write it this year.
The diagonal relationship, you still write it.
Diagonal relationship, give the diagonal relationship.
Lithium
and magnesium.
So the question is, in the periodic table, why are lithium and magnesium diagonally placed.
Placed.
Lithium and magnesium show a diagonal relationship because they have similar ionic sizes.
Yes,
The ionic
exactly.
size of lithium and that of magnesium. This is lithium, magnesium. We are just from saying that lithium is in group 2, in period 2. So what does it mean? Magnesium 2 plus. Their ions are nearly alike. In fact, their size, their ionic sizes are almost the same. That is why they have this diagonal relationship. And it does not end there. They have similar densities. Now the next question says, explain in terms of bonding why magnesium has a higher melting temperature than sodium in terms of bonding. So
Please follow up keenly.
when we are talking about bonding, we are looking at electrostatic force of attraction holding atoms together or ions together in a molecule or compound. So I read a question that says, explain in terms of bonding why magnesium has a higher melting temperature than sodium. Magnesium forms from it is already clear that the bonds in magnesium are stronger than the bonds in sodium. That is it. And what bonds are we talking about? Magnesium has what? Both magnesium and sodium, they are all metals. So what does it mean? They have metallic bonds. But now, sodium, let me show you something here that you might not know. Sodium is in group 1. So it has just one electron on the outermost shell. And that one electron forms the delocalized sea of electrons, right?
Exactly.
Now magnesium, we have magnesium, which has, each atom of magnesium has 2 delocalized electrons. So compare the number of electrons that are going to be delocalized. You're going to see that magnesium has more electrons to be delocalized. What does it mean? It means that the bond that is going to form, this metallic bond will be stronger than the metallic bond in sodium. Are we together? At the same time, if we had aluminum, which is 3 plus, it means that the metallic bond in aluminum will be stronger than the metallic bond in magnesium, which is in turn stronger than the metallic bond in sodium. So metallic bond strengths are not always the same. Are we together? Now, the next question, we are already in 3B now. State and explain why sodium and neon are found at the same position on the graph. Prof, they gave us a graph there.
Let me check. I don't think they gave us a graph. Okay.
State and okay.
Okay. Yes, there's a graph.
Yes, I'm seeing the graph. State and explain why sodium and neon are found at the same position on the graph. All right. So
this thing is coming every year.
This let me quickly put the graph here for you people. The sketch below represents a graph of Locke. Very good. I think this question.
Ionization energy
This question is
against
just being
atomic
carried
number.
from a past quiz, past GC question.
If they don't ask you to draw, if they don't ask you to draw it representing from carbon, nitrogen, oxygen, fluorine to neon, then they will give you an ask you question under it. It's coming every year, so just know that you will draw it.
When I put Z, it's because I don't want to write atomic number. Atomic number is Z. So now we have Cn. It goes like that, comes down to O, moves across F to neon. Okay, so this is what we have. This is the graph they're talking about. The graph below represents, I hope you can see the graph, represents the log, a graph of log IE against atomic number for some elements. Now that's why they say state and explain why nitrogen and neon are found at the same position on the graph. This graph shows the variation of log IE against atomic number Z. Now, I want you to know the relation between IE and log IE. IE and log IE are directly related. When IE increases, its logarithm also increases.
Yes.
So this is because some people will see this log and then they will now be confused. Please do not. Please also know how to define IE and IE1. They are very important. I will not be saying that here. So let's first of all start by stating clearly why sodium and neon. Is it sodium? No, nitrogen. Nitrogen and neon. You can see that on the graph by yourself, right?
Yes.
So nitrogen and neon are found at the same position on the graph. So nitrogen, it normally has a half-filled p subshell. That is 2p3. 2p3.
I mean, they're even understanding that 2p3.
Is it today you want to understand this one? It's revision, so you should just recall, not understand. Because if you need to understand, you have to start from. Okay, when we talk of nitrogen, if you have to write you can write out the SPTF notation for the electronic configuration of nitrogen.
Yeah.
It ends with 2p3.
3.
So, and normally you know that the p subshell has 3 orbitals, and these 3 orbitals means that each orbital receives 2 electrons in pairs like this.
A good clarification has been made.
So normally the p subshell that has 3 orbitals can take a maximum of 6 electrons. But now for nitrogen, the 2p subshell, which has the capacity of 6 electrons, is being occupied by 3 electrons, which means that it is being occupied half like this. So that's why we are talking about it being half filled. So I hope it's clear. So it means that what? Extra energy is being required to remove an electron from that stable arrangement. Once it is half filled, it is already nearly stable, though it is not full, totally filled. That is it.
Yeah.
Now let's look at neon and then see what is happening there. Neon now, it has a very high ionization energy as well. Why? This is because its own outer p subshell is fully filled. So even on the graph we are given here, you would notice that nitrogen and neon are at the top, but neon is more stable than nitrogen. Neon normally, even a Form 2 child already know that neon is having a stable octet structure, right? So it's a noble gas already. Its p subshell is having 6 fully filled electrons. So it is a very stable, and because of that, the electrons are strongly attracted to the nucleus, and because of that, they are very difficult to remove. What is ionization energy? The minimum amount of energy required to remove 1 mole of electrons from 1 mole of a gaseous atom or ion to form 1 mole of a gaseous positive ion. So to remove electron from an atom or ion, that is ionization energy. The more it is difficult, the more difficult it becomes to remove the electron, the greater the ionization energy. Now, we are done with that particular part. We go to Roman 2. Roman 2 is singing a song like this. Plot on the sketch
the representative graph to show neon and nitrogen. The next 2 elements after neon. Okay, let me see something. Let me first of all wipe the and answer the question the second time so that I will explain better. Okay. Plots on the sketch. The sketch I'm from wiping, or how? I'm just from wiping it, so but it's okay. Plot on the sketch the next 2 elements after neon. But it is not difficult to draw, right? This is how the sketch looked like initially. I really thought it was already a different question. So we have log of ionization energy, i.e. against atomic number Z. So we had carbon first, moving to nitrogen, coming down to oxygen, and then
passing through fluorine to neon.
Yes, that's good.
Let me put it here. Fluorine, neon, so that we have space. Now we just have to represent for the next two. After neon, what are the next two elements after neon? After neon, we have sodium and then we have magnesium. So it means that we have to represent for sodium and for magnesium. Now, but the question is from here, will the ionization energy increase or decline? We are talking about sodium and magnesium from neon, which is stable, right? So it's already clear to everybody. It has to fall. The ionization energy of neon is very strong, is high, great. Why? Because neon has a fully filled D subshell. Good. So because of that now, sodium here, it ends with the S subshell S1, which is partially filled just because it has just one orbital. So what does it mean? It falls. It falls to sodium and continues falling to magnesium. This is just what you have to do. It falls to sodium and continues falling to magnesium. Now, we have this very nice topic in organic chemistry that everybody is trying to run away from. But then I'll make it easier and a bit rapid there. Because when people see complexes, they are like
oxidation state.
Yes. So we have a complex ion. We are given a complex ion like this. Okay, this is the complex ion that we have. And the first question wants us to, calculate the oxidation number of cobalt or what the oxidation state of cobalt. How can we do this? It is very simple. It's not only in complexes or in organic chemistry that you have this. There are questions in organic chemistry and most at times in physical chemistry that you need to find the oxidation state. And this is the method. You are looking for the oxidation number of cobalt. So you let the oxidation number of cobalt to be X. Why? Because you do not know.
Some of you put here X, you're already crying. It's not matter, just follow up.
Let the oxidation number of cobalt be X. Now the next thing is you have NH3, which is this here, and it is neutral, right? So you need to remark that NH3 is neutral, meaning it does not have a charge. There are rules for assigning oxidation numbers. And then chlorine, chlorine, the oxidation number of chlorine is what? -1, right? Here we have two of them, right? We have two of them, so it means the oxidation number here is already -2. Then we continue. We have C2O4. This is an ion, C2O4. And even if you do not know that it is an ion, it is bonding itself to Cl2-. It is an ion that has a charge of -2, and because of that, its oxidation number is -2. What is left?
The dependence of ligands.
Now, the complex ion itself, please take note, because when the complex ion sometimes has a charge, it can be +1, +3, -2, then you equate it to that charge, right? But now it is neutral, and when it is neutral, you equate it to 0. And also, this ammonia here is neutral, so its oxidation state here is 0, right? Because it is neutral. So what does it mean? You have an equation of X plus what? This ammonia is neutral, so the oxidation state of oxidation number of ammonia here is 0 times 3, still 0. Then now -2 for chlorine, then again -2 for C2O4 2-. Yes, and you equate it to what? 0, because the complex ion itself is neutral. So when you do this, in fact, it's clear. X is negative positive 4.
Overall charge.
X is positive 4. So, and what does X represent? The oxidation number of cobalt. So, what does it mean? The oxidation state of cobalt in this complex is positive 4. Okay, so we are going now to Roman 2. Give the formula and name of the ligand. Very important. Let's go there.
After what you want to present, identify all the ligands. And for you, they never cry because they don't even know the difference between the ligands and what.
I'm telling you. Okay, so give the formula and name of each ligand in the ion. Okay, so what does it mean? I have to write that ion again. The complex ion. We identify the ligands in that complex ion, and then we get to be able to wow. And then there's a replay somewhere. But and then we now should be able to name those ligands. You see, it's nothing big. Okay, this is the complex ion CO, that's cobalt, NH3, 3 here, then Cl2, C2O4. By this time, some people have already skipped a lot of questions going to organic chemistry, and then they are still unable to answer any question there. But nonetheless,
we'll identify the ligand here for you guys.
we are going to identify the ligands for you people. So what we need is the formula of the ligand and the name of the ligand. The first ligand here is this NH3. You can see NH3. That's the first ligand. And we'll identify them first so that you properly understand. Let's identify all the ligands here. There are 3 by looking, right? There are 3. So we have to identify them. Then now we'll come back to name them. The next ligand we have here is Cl minus, right? Cl minus. And the third ligand we have here is C2O4 2 minus. Now let's proceed to name them. I'll use red. Let's proceed now to name those ligands. NH3. Some people will say ammonia, and I'll say no. It is what? Amine.
Good.
Now the next ligand is Cl minus, which is chloro.
Some people will say chlorine.
Some people will say chlorine, and they will
no.
fail. And next year they will come again, and the next is what? The oxalato. The oxalato. So that is it.
Some people will say oxalate. We don't want that.
Those who will say oxalate here, because majority of the people they will say oxalate. And it will not go. It will not go. So, and please, this should just hint you that you should know the formula and name of what? Ligands. Know how to identify ligands. It's not today that you will learn everything. There are some of these things that you should not crack your brain too much on things that you do not understand for 9 months. You want to understand in one night. It's revision. So we are just reminding you of what you have been reading. Because we do not want things to happen, and then they say that we did this and we did not do the other one. Okay, I'll continue with Roman 3 now. What is the coordination number? Sorry, what is the coordination number of the metal atom? What is coordination number? What is coordination number? I don't know why I'm too quick on wiping that particular complex ion without knowing that it has a lot of questions just beneath. Please, I'll put it back on this will be the last time, because the last question on this complex ion. Cl2, then we have C2O4. That's it. All right. So the question says, where is it? What is the coordination number of the metal atom? So we want to look at the number of donor atoms that are available that the center metal atom can receive. If you do not know how to define ligands, you cannot define coordination number, and you cannot find the number of coordination number.
some years they will start by asking you what is a ligand.
What is a ligand? And then you should be able,
And
then sometimes they'll
I
still
will
ask
follow
you
by
what
what
is a
they-
coordination.
And always followed by what? A bidentate ligand.
So now,
So tomorrow don't go and say I did not tell you, because you will see bidentate ligand there. And you know what happens to bidentate ligands. So reply me on the comment section what you know about bidentate ligand. Then we'll get more explanation to throw more light on that.
keep the comment section busy,
Yes.
because that's where we know that you're
That's where we know
understanding.
that you're understanding.
We're doing
And
this for you, so if it's like, if you're not understanding, we better
drop
close
all the
it and then
questions
you-
on the comment sections. I will answer you directly on the board. Prof, you can continue.
Next question. Now, I want to say that what you did in Roman 2 of this question was to help you answer Roman 3, because they're asking you the coordination number after they have asked you to identify the ligands
Ligands.
and name them. So now we were able to identify the ligand. We said we have NH3. We said it is the amine. We said Cl minus chloro, and then we said C2O4 2 minus oxalato. Yes. Now we have to identify the number of donor atoms present. For example, NH3, right? We have 3 of them. What does it mean? We have 3 donor atoms. Cl minus, we have 2 of them. It's clear, you are seeing this on the board, right? So we have 2 donor atoms here. Donor atoms. Donor has just 1 N. Okay. Then oxalato now is a bidentate ligand. What do we mean by bidentate ligand? It is also a 2 donor atom. So oxalato is a bidentate.
Even after telling you people what the bidentate ligand is, nobody had dropped on the comment section. You want to tell me you knew what it was a bidentate ligand?
No, they knew already. Probably.
Good. That's good. Yeah, we are working on an A grade tomorrow.
So what are we trying to say here? We have the coordination number to be 3 plus 2 plus 2. This gives you 7. What does it mean? The coordination number of this complex ion is 7. It's clear, right? Clear, very clear. I think I can see that on my camera. I can see that. Now we'll go to Z. We'll go to question 3, Z. Now, I read the question.
So where is it?
I know, Prophet. Don't worry. Where is even the Z? Okay, give the complex formula of diaqua dicyano copper 2. This is where people start understanding that life has 2 colors.
Dicyano copper.
And this
2.
complex is not even difficult. There are
Very
complexes
easy.
that they will give the name, and then you are thinking about
This
your
one
life.
is very easy. This one, just looking at what is even there, you can write it. I'm sure Mr. Joy has done this thing with them. This particular complex in the center there, for those that are off-site.
Okay.
But if you ask most of them now how to write it, they will give you a wrong something. Please take it down, because you are going to write it tomorrow in the GC board. Somebody say amen in the comment section.
So, let me look for. We are on D. Give the complex formula of diaqua dicyano copper 2. So, this is something easy. There's nothing there. Now, you have heard us talk of what? Copper 2. Copper is U. Copper 2. U is the symbol. O. Yeah. Copper 2. Copper 2 is written as what? Cu 2 plus. Then you have also heard in the name, they have said diaqua. Diaqua. Aqua means what? Water now.
Water.
So diaqua means 2 water. Diaqua, when you hear that diaqua, it means 2H2O.
2 water.
2 water.
People only know how to watch Aquaman, but when you hear Aqua in book, you don't know.
Now, you also hear something like dicyano. It means 2 cyano ligands. Cyano is a ligand. This is how the cyano ligands look like.
In
Cl
organic chemistry, they know
minus.
what cyano is.
Exactly. So this is Cn minus, it is the cyanoligand, and then they are talking about dicyano, meaning that two cyanoligans. So now you just have to now put these things together. I can leave you here now to complete it. So you just have to put these things together, and then you have the complex formula. You have Cu, then you open your bracket, you put your 2 water now. You put your 2 water. Then you now open another bracket, you put your cyano. Yes, you put there are 2 of them. Close the bracket before you put 2. You put 2, then now you close it. You remember that these complex ions are always written in square brackets. Yes. So when you write it like that, you put it in square bracket to tell us that this is the start, this is the finish. That's all. So this is it. Okay, now. Now we are on Roman 2 of that Z. Okay, question says, what type of isomerism does it exhibit? What does what exhibit? Diaqua, dicyano, copper.
Don't look at it, you should already know.
This. What type of isomerism does it exhibit? Is geometrical. Is geometrical isomerism, which is what the cis and trans isomers.
So looking at it,
Yes.
you already know the cis and trans.
Cis and trans isomers. So we'll not waste time on that.
We're just
so
changing the position.
We have now to
of
give. They have not ended there. Oh. They said now that we have said the type of isomerism. Yes, in Roman 3, give those isomers, right? So let's give the isomers. So it means what? Since we're saying it is geometrical isomerism, we should give the cis and the trans isomers. That's it.
Don't go and say geometrical isomerism and go and give another isomer.
Yes, when they now say, you just go and put, optical isomerism is very easy.
Yes.
You just reflect it under the mirror and you're sitting and smiling.
You go and put broken line.
So for the cis isomer, we already wrote it. I will still just put it for you people so that by the time we put the isomers, you should see clearly. We have copper. I wiped the bottle early. I don't know. Copper and chemistry. The equations are just related. You see. We have H2O here. So then we have Cn. Then we have 2. We put that in the square bracket. This is our complex. So we have said it exhibits a geometrical isomerism, which means the cis and trans isomers, or cis and trans isomerism. So we have to give the cis and the trans. So for the cis, we have copper, yes, H2O2, Cn2, yes. Then for the trans isomer, we have copper, open bracket, yes, H2O2, yes, then, okay. So we'll now just continue with the next part, 3E. 3E. Okay. I read the question, if at all I can see it there. Okay, that's it. Nitrogen and sulfur react with oxygen to form their dioxides. Normally, right? Nitrogen dioxide and sulfur dioxide. Write equation in each case to form the dioxide of the two elements. Exactly. Yes. So it simply means you just have to write. In fact, what am I talking?
As disproportionation.
Let me just talk directly with the equation. Okay.
Nitrogen first of all.
That's disproportionation reaction.
Sulfur plus oxygen.
So
that's all.
We have nitrogen. We're talking about nitrogen. Nitrogen exists as a diatomic molecule, N2.
Good.
And oxygen, O2. It forms NO2, right? So this juncture, you just have to balance it because it's not balanced. How do you balance this? You put 2 here, you put 2 here, and it's balanced. Okay. Then now for sulfur, sulfur exists just as S, right? Plus O2, and this gives you SO2. Simple. So these are the 2 equations they need. Imagine at advanced level, they are asking this kind of 2 equations.
Anytime you just see a question like that, just know that it's disproportionation reaction. The next thing you do is to add an oxygen to the two. That's just all. You just take the first one, add oxygen, and you have the gas. Take the next one, add oxygen, and you have the gas, and make sure you balance the equation.
J'espère que c'est clair. I hope people are watching.
Yeah, they are doing.
People are watching. Guys can be sleeping there.
Oh, they are watching. They cannot even sleep. It's their final revision, and you know.
Just coming back.
If they sleep now and they drop something technical, what would they do?
I'm telling you. I at Mangola was only hearing 2 a.m. and 3 a.m. I was like,
so you know, understanding.
I did not even understand what they mean. I was not understanding the meaning of 2 a.m. and 3 a.m. It's like I'll stay up to see what will happen, whether I don't get. Okay.
Yes, that was it for the break. Let's go back.
The
next question says, what
Roman 2?
Yes.
Nitrogen dioxide disproportionate
in water.
In water. That's the mean. That's simple. We get there. What is disproportionation? Yes. So disproportionation is a type of reaction, right? It's a reaction in which the same substance is simultaneously oxidized and reduced at the same time. That's the meaning of disproportionation reaction, right? Or a reaction in which oxidation and reaction takes place at the same time for the same species. That makes the difference between disproportionation reaction and redox reaction. Yes, because in a redox reaction, one species is oxidized, another species is reduced. Yes. But in a disproportionation reaction, the same species is oxidized and reduced. J'espère que c'est clair. Write. Wait. Let me look for. Okay. Write a disproportionation reaction for nitrogen dioxide in water.
Just take nitrogen dioxide plus water.
Water. So I'm not really
write down nothing. Just take nitrogen dioxide plus water. No, plus water. We cannot be helping them.
We cannot be helping them with this one.
Yes.
We just go to nitrogen. The next so I'm waiting the comment
section. Yeah, we're waiting on the comment.
Nitrogen dioxide plus water. You should be able to predict the product and balance the equation. Then now, by the time you're done with that, send in the comment section, because I have to explain to you how it is a disproportionation reaction, right? How exactly which species there is being oxidized and reduced at the same time. So that's it.
Drop it in the comment section once you're done, as you're following up. If you don't drop, then we assume everybody understood it.
Don't drop. About a decade ago, we wrote our own. So now we are on Roman 3. I think, after doing this one, these guys can go and sleep now. Vous faites même quoi à l'air là, debout? They are not sleeping.
They can sleep now. These students are wizards. Some of them are even texting me on WhatsApp and wonder.
It's 1:30 and guys are not sleeping. During mock, we did not see this. Okay, anyway.
Wizards, so.
Let me do Roman 3 and then give you space.
Okay.
Roman 3. Roman 3. So that will end number 3. Then the next question will be Roman number 4.
The word industrial use of a named compound of sulfur. As simple as that. What do we use a named compound of sulfur of? An example, what? Sulfuric acid. Where do you see it? Fertilization.
I don't lost internal organic chemistry. I see state Markovnikov rule. Can you imagine? See as question sweet.
And you will see Markovnikov rule tomorrow. As I dey talk and so now already treating and now I don't already you say you must see tomorrow.
Give one industrial use of a named compound of sulfur. Is this a question for us? The first thing you should think about is what?
The sulfuric acid.
Yes.
Used in what? Yes. Fertilization.
Exactly. To manufacture fertilizers such as maybe ammonium sulfate and some superphosphate fertilizers. Yes. Then we can also use sulfuric acid to produce detergents. Yes. Yes. You can add that, but the main use is for fertilizers. And then it also helps in batteries. Yes. and the refining of petroleum products. Yes, sulfuric acid. Now this is it, but I'll return to question the previous question.
That you ask.
Nitrogen dioxide. Yes.
If it has been dropped in the comment section, then you answer it. If it has
Yes.
not been dropped in the comment
Then
section,
it's your cup of tea.
then they
Who
know
will
what
say
they want to
do.
write tomorrow. Then you give room. I continue from there. That's their problem.
So let me see. Let me just eye something.
Have they dropped it?
A lot glory. This guy is this guy is not doing GCE. Eh? If it's the
The
one
second equation.
all right, I've not seen
not
any.
balanced.
I've not seen anything.
Balance.
Mais pourquoi? You are
So-
not allowing GCE students to be studying. You two are there.
So
Even
us
medicine
to study.
students, they're not leaving
They are
us.
not leaving us. Can you imagine? They know what is awaiting them in concours.
No.
It
I recommended that they should be part of it because they will benefit a lot.
A lot.
Nobody has commented that in the comment section, so
No, she has seen it. I wanted to just clarify her that the equation was balanced. Let her check well.
Okay. Anyway, when we are helping people, we should help throughout now. So it was nitrogen dioxide
Plus water.
plus water. Okay, this normally should give you nitric acid.
Nitric acid plus
HNO O3, yes, that's nitric acid, and then HNO2. This is it.
hydrogen dinitrate.
Yes. Now, how is this a disproportionation reaction? How? We are looking at nitrogen. Nitrogen is the species here that is being oxidized and reduced at the same time. Yes. It changes from oxidation states 4. If you calculate the oxidation state of nitrogen is nitrogen dioxide, the oxidation state will be +4. See, I hope all medicine students are attending this thing. Because Prof will not come and do this thing again. Eh?
Oh, we don't do
I want to believe that all medicine, because
Those
for
medicine
engineering
concours.
guys,
They
those
don't
guys
need
they
it.
have their witchcraft.
No, they don't even need it.
They have their witchcraft
normally.
Yes, they can. I don't know how they used to, but when they are to pass, they will pass.
Yes.
When they are to fail, they will fail.
Okay. So with lessons today, we are not
I
coming
hope
back
all
to
those
this.
guys, all
So
those
you are already
medicine students
preparing
are-
directly for your concours too as well. So for those that are not into collaboration, you do it kindly to inform some of your colleagues that you are in touch with them to join now and get in touch with us.
So the oxidation state of nitrogen changes from +4 to +3. That is what? Reduction, right? Then changes automatically from +3 to +5. That's again oxidation. What does it mean? The oxidation prof. This is serious. Like I'll continue that question.
Sure, no.
Is it for somebody always to start?
No, we are doing too much.
Like we'll close the class then now. Prof, you have the ball. I'm done.
the.
Just continue with number 4 now.
Okay. So I'm going to continue where Prof ended. He has ended and explained that was the industrial use of sulfur. Now we are going into the next question, and this question is a standard question that comes every year in the GCE. Yes, I know you are not yet seeing my face. I'll soon be standing up. Don't bother. You know, standing up for long and be teaching is not easy. When the board requires to call my attention, I'll be on the board. Okay. Now, most and famous, what do you notice? The next question says the equation for the reaction of a bromate with a bromide is given below. So I'm going to write down this equation in the board. That is bromate plus bromide. That's loose. Plus H plus concentration. I give you what? Bromine plus water. When you just this thing, we are already seeing halogens. You don't even need to Once you already identify a question where it is from, you are already talking about halogens. And these are the kind of things you still go and see them concours, and you still go and write your hands and come out and say you have written.
I'm telling you.
And they are written. So when you do this, you notice we are talking about halogen. Now the question goes, give the oxidation state of bromine in bromide. I don't even need to read this thing. What is the oxidation state of bromine in bromide? What just talk of oxidation state now like this? It should already be there. So I'm not going to give that one. Now, which of the reactants is the oxidizing agent? Which of the reactant is the oxidizing agent? Somebody will still want me to explain the oxidizing agent. Oxidizing agent are just simply what? The ones that gain what? Electron. So the one that have negative there is the oxidizing agent. And which one is that? The bromide. BRO negative. So this is the oxidizing agent. Yeah. And the oxidation state of bromine in bromide, looking at it, this is 3 minus overall, you send 2, 5. Plus 5. It will give you a plus 5. Prof just did that. I don't explain again. You already know what to do. Now, the next question proceeds, says write a balanced equation for the reaction. Now we want to write down a balanced equation for this very reaction. They're just simply asking you to take down that reaction and balance it. Now when we want to balance this equation, we take into consideration the oxidation state of bromine. If we don't take into consideration the oxidation state of bromine, you won't be able to balance this equation. Now, let me balance the equation. You should see, we have the bromide, BRO negative 3, plus the oxidation state of bromine was 5. So I'll put 5 bromine minus plus hydrogen to give you what? Bromine plus water. Now let us start balancing the equation and be going gradually. 5 bromine, how many bromine is there? We don't even know how many bromine is there. We just have 2 bromine. So what do? I'll put 3 here. Now 3 and 2, we have 6 bromine. Bromine means you are gaining 1 here, meaning it makes a total of how many? 6. Now 5 bromine, 1 bromine, 6, 6, 6 bromine. Bromine is balanced. Now let us go to oxygen. Oxygen is negative here. That's the oxidation state. It means that gain another 1. Keep it aside. Look at here. We have 3 oxygen. How many oxygen do we have there? 2. What do I do to balance it? I put 3 here. Now how many hydrogen do I have? 6 hydrogen. Now how many do I have here? I have 1 hydrogen here. So what do? I come and add a 6 here. Now what have you noticed? That equation has been totally balanced. Bromine 6, 6. Oxygen 3, 3. Hydrogen 6, 6. And we have balanced the equation. And that's why the oxidation state is very necessary. I do not want to go and be explaining that how you balance, you read this after you calculate the number of oxidation. No, we have already calculated the oxidation state of bromine. So when I'm just writing down this equation, I take that oxidation state and multiply where the bromide ion is found. Once I multiply it on the bromide ion, automatically I'm already balancing the equation. I write down the equation the way it is and introduce hydrogen. I will not go again and be putting and start counting the number of oxidation state on the right, the number of positive this thing on the no. Once you have already calculated the oxidation state of the bromide, you take that oxidation state and multiply on the new equation, then leave the hydrogen, write down the equation, and you just start balancing, and everything will just come out and you leave. That is just the trick. We don't have time to go and be counting number of oxidation, number of this. That's the trick with it. Now let us go now to the next step, the next question. The next question now says define atomic radius. It means that we have dived now into what? The periodic table. This is typically the periodic table. You don't need anything. What is atomic radius? Atomic radius just simply have to do with distance. The distance from the nucleus to the outermost shell of electron. And it varies. Once I'm explaining, I'm going at time. It varies what? Down the group. That is down group 1 and group 2 element due to what? Due to added shares. And between group 1 to group 2 element, group 1 atoms are very large because they have fewer protons pulling electrons inward as compared to group 2 element. So what are we saying? We are saying that it varies down the group and it varies between the group. When it varies between the group, that is across the group. Let me use the words you normally know. It varies down the group and it varies across the period. Now, when we say it varies across the period, that is because group 1 element has what? A larger atom, thereby drawing fewer electrons to themselves as compared to group 2. Atomic radius, the distance from the nucleus of the outermost electrons. The distance from the nucleus to the outermost electrons. When you hear radius, we are talking of distance, my brothers. Don't forget. Atomic number. I will not go and define the atomic number. Yeah, my brother. I even defined atomic number in the beginning of the class when we started. I defined atomic number in the beginning of the class. So I will not go further to be defining atomic number. Now, explain how atomic radius varies down the group 1 and between the groups down. Prof, just look at something. I did not even hear the question.
Yes, I'm telling you.
But once I gave atomic radius, I already explained
that
down the group and across the period. When you hear between the two groups down, they are simply telling you that across the period. Don't want to be hearing grammar. The only thing that I've done this year with the GC is that they have changed language. They have complained that they do not want those types of repetition. Thereby, they have changed the language in setting. It is just question interpretation that will kill most of you people this year. So I already explained it. I'm going to skip. Now the next question says, complete the table below, giving the formula of the oxide and chloride of the element. This one is a day job now. Elements, we have lithium, beryllium, boron, sodium, phosphorus, and chlorine. Now, you already know the oxide that will always be formed. In lithium, when it comes to oxide, what do we have? We have lithium oxide. And don't forget that oxygen is 2, lithium is 1. When you cross multiply, this is what you have. Lithium 2 oxygen, which gives you lithium oxide. You already know lithium, oxygen 1, 2, cross multiply. That is it. Something that you have easily seen. Now, the next one, let us go to chlorine. Chlorine is 1, lithium is 1. It gives you what? Lithium chloride. There's nothing there to do. Beryllium. We have what? Beryllium is 1, oxygen is 1. So you have what? Beryllium oxide. Okay, thank you for that. So you have beryllium oxide. You go to the chlorine. Beryllium chloride. Chlorine is how many? 2. Beryllium is how many? 2. Chlorine is how many? So you have this. Beryllium, chlorine, you have 2, 1, cross multiply, you have beryllium chloride. BeCl2. That is BeCl2. You go to the next one. We have sodium. Masa, sodium oxide. Should I still tell you how we write sodium oxide? You already know. Sodium chloride. This one is normal. It's already a salt. Your kitchen salt. You don't have to be filling this kind of one. Go to phosphate. Phosphate has 2 ways. The best one is what? People already know is that one for 5. The one we used to say pentaoxide. That's in phosphate pentaoxide. Never forget, master it. That is P2O5. Phosphate pentaoxide. Chlorine. What? Phosphate pentachloride. Never forget it. This one is standard. We also have phosphate trichloride. These are chlorine for phosphate. You can put anyone there, they will still mark it correct. The essence is to know what you are doing in this case. Now, chlorine. Chlorine itself will give you what? We have the Cl2O7. That's in our prof. Then we have chlorine itself to chlorine will give you what? The di, the chlorine double atoms. Now, the next question says, oh, very interesting. Which of the chlorides could form a dimer? I just talk of the dia here now, prof. Do you need anything again? Which of the compound could form a dimer? This. When you look at it, most of them, they don't even know which of the chloride could form a dimer. These children are so at times pathetic that because they do not even read, they forget. It is clearly stated in their book that note better. The only compound that forms a dimer is aluminium chloride. But you see most of them, because the next question here on the table is saying which of the chlorides forms a dimer, and there is no aluminium here. You will notice some of them go and telling you lithium. Some of them will just come and choose the answer only here and put it there, forgetting that it is a trick. They want to drag them into the trick to push them to fall. So note again, I'm telling you today, the only compound that forms a dimer is aluminium chloride.
There's no structure of aluminum chloride.
You know.
AlCl3, Al2Cl6.
That
They
is
don't know.
good. So that's a trick. So don't go and choose anything in that place and write, and you come and say tomorrow we do not teach you. Now draw the structure of the dimer. This is already it. Everybody can draw a structure of a dimer. You have aluminium, you have the first chlorine, second chlorine, third chlorine. Now in this case you have double aluminium, which forms a dimer like this. What do we have? 1, 2, 3. Let me put it the way it will come our way. 1, 2, 3. 1, 2, 3. Then you put your bond like this. You have Cl, 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 Cl.
So please draw it well.
Yes, that's why people.
You know how.
These students are very funny, very pathetic.
I don't tell you, I don't know why body.
Very pathetic set. So the dimers will give us now we are adding a second aluminium compound. We put a bond here, Al. This one comes here again to Cl, Cl, Cl. And now there is a bond formed between these two chlorine atoms, which are lone pairs of electrons here like this. Because these two are like that, they don't even know. There are two bonds here that are formed that give the lone pairs of electrons. So this is the dimer, and the other one is like this. So please, this will come tomorrow. That's the fifth thing I'm saying will come tomorrow. More time GC board will find me lock up.
We know I'm trouble, yeah.
Now the next question.
Prof, I'm waiting for number 5.
Okay. The next question. The following elements are in the same group of the periodic table. Carbon, silicon, germanium, tin. I don't even need to read. It's already a standard something now.
That one is already short.
Okay.
You see that question, you read before you answer.
Choose from the oxide two that are acid. You connect they are carbon monoxide and silicon dioxide. Carbon dioxide and silicon dioxide. Those are two that are acid. The two that are acid, I have carbon dioxide and silicon dioxide. If you don't understand anything, please drop in the comment section. If you don't make the comment section busy, we will not attend to you. No question.
We will not know your problem.
No question will not be attended
And I'm
to.
here looking at comment. No comment is coming.
Okay. Once my colleague is on the board,
everything.
I'm on the comment section. Once he's on the board, I'm on the comment section. Once I'm on the board, he's on the comment section. So drop all your questions and everything will be clarified for your doubts. Now, at amphoteric, I don't even need again to read. We have what? We have germanium dioxide, monoxide. We have tin dioxide. We have they say two now. It's okay. Although there's still one. That's how do they call that compound? PB. Lead monoxide. That's an amphoteric compound. If you don't understand what are amphoteric compounds, ask so. Don't go tomorrow because you want to do cram you go and say I forgot what my teacher put on the board. Okay, let us go. Show with equation the acidic property of one of the acid oxide. We can equation acidic property of one of the acid. Now, let us look at carbon dioxide. If I add carbon dioxide to water, Prof, I'm going to have hydrogen carbonate.
Yes.
Dihydrogen carbonate. That is carbon dioxide plus water will give me the dihydrogen carbonate. That's it. That's just all what we want to see. That's the acidic property with the aim of an equation. That's just all. Now, the next question says, okay, Prof, I think you can take
Number 5.
Yes, come on.
Okay.
Okay, let me give the board card to Prof. Why I can have some small snacks. People will not kill us.
Okay, so why is the board trying to be blurred? Okay, the camera is okay now. It's because of the movement.
Prof, keep on, guys.
Yeah. D'accord. We have to keep on moving. Okay. We're left with 2 short questions. You know, organic chemistry is always short.
Organic chemistry is already done for the day.
Yeah.
But those that they have opened their phone and they are sleeping, now they know. If you come online, they sleep. Now you know. This class was scheduled for 3 hours. If we started at 9, we would have finished within that 3 hours. But you people,
We're still finishing within 3 hours. The
But you
thing now
people-
is that the 3 hours is taking us to around 2 a.m.
to 2 a.m.
Yes.
The morning, and now that 2 a.m. you have to go to bed and get up again at 1 a.m. That's how we're doing.
Sleep at 1 now. All right.
That's to say you're not supposed to sleep, but you're supposed to bring time back.
Don't even sleep at all.
Don't even
You
sleep.
just have to.
I don't even know why you're sleeping on the eve of GCE. You have been sleeping. Go tomorrow and write. When you go and write, once you finish writing, you will have a whole day to fall like that on the bed on that last day after partying. Prof?
Yes.
And sleep.
Okay. Don't mind as we tell you that you sleep after GC. After GC is prepared conclude, there's no sleep for you. Now, we are in question 5. You know very well it's organic chemistry. This is where a lot of people have problem with chemistry. This is where some people, when they get here, they leave it empty. I mean, empty. Sometimes they only look for place where they say define catenation. They can define that one. Then they leave the rest empty. But I don't really know
what is happening. Meanwhile, the cheapest pattern.
So now we are going to have the question 5. Question 6 is even the shortest, but I will do just question 5 so that Prof completes question 6 and then close to people. I'm going to read the question and then just answer directly. I'm not going to be going too detailed, you see.
This is organic.
But
you go
I'll explain for you to understand. So that's very sure. I can assure you that. Now, is it okay? That organic compound exhibit variety of multiple bonds, right? That is sure. Using hydrocarbons illustrate the type of bonds in some organic molecules. So we have a small table. We need to give a hydrocarbon, the type of bond, and give an example. So we are talking about hydrocarbon. There are 3 types of hydrocarbons, right? So we are given 2 spaces, but I'll just give you all the 3 at once. We have what? The alkanes. We have the alkenes. And we have the alkynes.
Most of them could not interpret this question.
No, they can only define catenation.
Most of them could not interpret this question. I'm telling you, Prof.
Now, when we talk of alkenes, we are talking about carbon to carbon single bonds, alkenes, carbon to carbon double bonds, and alkynes, carbon to carbon triple bonds. Now, an example of alkanes,
even the easiest one.
You can even say methane.
Methane, the easiest one.
Methane gas, the one you use to cook conchab now. Your kitchen gas the cooking gas is methane.
Thank you.
You can use ethene here, or butane if you want. Here you can use ethyne, for example. Ethyne. So methane is CH4. Let me just add they did not ask this one. Methane is CH4, and like I already said, I'm going to explain for you to understand. I'll just give you already the general formulas, right? C N H 2N plus 2. This is the general formula for all alkenes. This is it. Then for alkenes you have CnH2n. For alkynes, you have CnH2n minus 2. So that means you can have the structural formula for any hydrocarbon that you want.
Which is already even the example.
So what does it mean? I've answered more than 3 questions in one in short time. So let's just continue. We have 3 things to define, and I'll just define. We have
the bond types.
I think they are similar.
Any student are fun here. Maybe very soon you say, so what is the bond type? The bond type bond, double bond and triple bond. Those are the bond types.
Now we are defining 3 things. Excuse me. Okay. Carbocation. We have carbanion and we have electrophile. Yes. So let's go ahead to define them. We're starting with carbocation. A carbocation is an organic ion in which a carbon atom carries a positive charge and has only 6 electrons in the outermost shell. We can have an example of CH3, C plus. Yes, CH3 here, then C plus. Okay, now let's go to carbanion. Carbanion. So carbanion is an organic ion.
Vice versa.
It is just the opposite of this, right? So carbanion should just be what the opposite of carbocation, but I will define it for you. It is an organic ion in which a carbon atom carries a negative charge and possesses a lone pair of electrons. You remember Mr. Lone pair?
Wow.
Since then, it's difficult for me to say lone pair of electrons. So I keep saying lone pair, lone pair, boon pair, repulsion, boon pair, boon pair.
Repulsion. Oh.
Well,
We had colleagues.
I hope we are understanding. So for carbanion, an example is CH3 minus. Now, electrophile. Now, this is never a problem for anyone. If you have a problem at carbocation and carbanion, now the problem has been resolved. But if you have a problem to define electrophile, nucleophile, and free radical, I don't know. What is an electrophile? Electrophile simply means electron loving, you see. So electrophile, these are electron deficient species. Deficient species that they accept pairs of electron to form covalent bonds. So the fact that they accept pairs of electron means they are electron deficient and they are electron loving. That's why they are known as electrophile. You see, so it means all electrophiles are positively charged.
Anytime you forget electrophile, you think of how you used to love that girl in school.
Now I even enjoy these students because my own days I was only busy studying. I didn't know that school life can be good. I had to kill myself with book. Now you are seeing how they are enjoying school life, and you're like if
you were in that time.
Okay, now we are on Roman 4. Just as we are smiling like the question is going over.
Yes.
Roman 4 says, which is more likely to be attacked by an electrophile, a carbocation or a carbanion?
Loving.
Explain. We have already defined, right?
Electron loving. So you don't even have to take that again, Prof.
Should it be a carbocation or a carbanion? It is very simple. It's a carbanion, and I'll explain why. Do I need to explain why? No, but I'll still explain. A carbanion is more likely to be attacked by an electrophile. Why? Because a carbanion is negatively charged. And then it is electron rich. Now, an electrophile needs to attack electron rich centers or electron rich species because an electrophile is electron loving, you see. So it is a carbanion that is likely to be attacked by an electrophile because an electrophile needs more electron. It's an electron acceptor. I hope you have now understood. On the other side, we have carbocation that are richly electron deficient, and they usually attack rather they're attacked by nucleophiles, you see. Yes, and nucleophiles are those ones that they are nucleus loving. So what does it mean? They need more of those positive charges. Meaning, the answer to this question is simply carbanion. Now, Roman question C, I believe after C is D, after D is E, and that's all. Something like that. So C.
The hydrolysis of the hydrocarbon is given below. Plus this to give that. What type of hydrolysis is present by the reaction?
What type of hydrolysis is represented by the reaction? So, see, if it's like we had time, I would have just said that you people should say something in the comment section, right? But that time is not there. Okay. So the type of hydrolysis, what type of hydrolysis is represented by the reaction? The hydrolysis we have here is nucleophilic substitution hydrolysis. Yes. The hydrolysis we have here is nucleophilic substitution hydrolysis.
And why?
That's SN1 reaction. Yes, SN1 reaction. And then
already
we are going to
explained
answer the
it
question of
properly.
why, because very soon, because the next question talks of what the mechanism, right?
And you already
Mechanism.
explained it when you were talking of electron logging.
Exactly. So now they say give. So this is an SN1 reaction, and what is SN1? Substitution nucleophilic, right?
Yeah.
Now, give the mechanism for the reaction. We have a mechanism in two stages. The first stage is going to be the formation of the carbocation, which is the slow step. And then the second step is going to be the attack by the hydroxide ion, which is now the fast step. So I'll put it here for you. It is for this particular reaction here. So we just want to put the mechanism now. We have first of all CH3, then 3. Okay, then we have Br. We have CH3, 3, C plus. You can see what is happening at this level. Plus Br minus. This is the first step, the slow step, which has to do with what? The formation of the carbocation. The next now is the attack.
Itself.
The attack itself, and the attack happens. This is a slow process, the slow step. Then the attack is the fast step.
Yeah.
So the first step is the attack by the hydroxide ion. So we have again CH3, we have C plus, OH minus comes now to attack. You can see that. So at the end we have CH3. Okay, then we have 3 COH. OH comes to attack, and this is the result. So that is the mechanism, and that's the end of C. We're now going to D. Okay. I'll read D directly, and I think D is that question I saw about Markovnikov's rule. If you're writing advanced level GCE, I mean you want to write organic chemistry and you don't know, I think Madame Lucon, she's the one with this thing here.
Yeah,
And you don't know Markovnikov rule, they are coming to write what? Meanwhile, you know that it will be there.
Yeah,
those things that you already know that will come, and then you have not studied. It means, what have you studied? Sometimes I just want to wonder. So you can see Markovnikov's rule. It means that the question 5 is nearly over. And that means our goal of completing this particular paper will be achieved, because in a short while, you see. State Markovnikov's rule. Now, Markovnikov's rule states that when an unsymmetrical reagent, such as HX or H2O, for example, adds to an unsymmetrical alkene, the hydrogen atom attaches to the carbon atom that already has more hydrogen atoms, while the other part attaches to the carbon atom with fewer hydrogen atoms. That is Markovnikov's rule. Now, they never ask you to state a rule for nothing. When they tell you state this law, state this rule, the next question you will use it, right? That's just how it is with the setting of exams, official exams. Now,
a Markovnikov rule is coming again this year. Somebody can say amen in the comment section.
Some people are rejecting it to fear. Now, yes, so you better just know it before you move into the hall, because there are those things that you know yourself that they are going to be there in the exam. Yes, that they are always there in the exam. So, okay, now we have
give the symmetric name of the compound.
Okay, I think then after that we have show how the rule is applied with an organic compound.
Yes.
It means at this level you have the choice to choose any organic compound and show how Markovnikov's rule is being applied. So you see that it's even they have not given you a compound to use. You have the free choice to choose any compound that you want. So you
Yeah.
can just choose the addition of maybe hydrogen bromide to propene, for example. So let's do that. Let's do that.
Bromopropene.
Exactly. So let's do that. Let's have something like CH3CH. Now, we are adding hydrogen bromide, right? So we have CH2 plus HBr. This now should give us CH3 CH3 here. CHBr. Wait. This should give us 2 bromopropene. 2 bromopropene, right? So you have CH3. That is it.
Let me see that.
Short and simple.
Good.
Hydrogen adds to carbon, already carrying more hydrogen. So that's Markovnikov rule, right? Carbon is already carrying many hydrogen, and hydrogen comes now. And instead, add to that one so that the rich can continue to be rich and the poor continue to be poor.
Bromine there could be any halogen except what?
Yes.
Iodine.
So any HX.
Any HX except iodine.
So for Markovnikov rule, we want to remember it easily. Just consider a situation where those who are rich should continue being rich, because it simply has to add to the carbon atom having the higher number of hydrogen. You see, so money is easily acquired by those who already have money. You can attest to that. Yes. And those who are broke, they are likely to remain broke. It's not our fault, right? Now we go to E. E says give the systematic name of the compound. Okay, the compound is CH3CH double bond CH then you have CH3. So we have to give the name of this. What does it mean? You just need to know how to name organic compounds. That's just all.
So just go fast. Longest chain.
Yes.
Presence of double bond.
You just exactly. You can already see a double bond present.
Presence of an alcohol.
Exactly.
Or a hydroxy group, because there are 2 ways you can name it.
So you have to number the from the end. For example, you can see also the presence of OH here. It is one of the key points you have to start, right? So the systematic name of this, count the number of carbon atoms in the longest chain, you will see 5. So what does it mean? The prefix will be pent. That's already it. And then there's double bond, meaning that it's an alkene, right? I already explained that. The single bond is alkane, double bond is alkane, triple bond is alkyne. So it means that the systematic name here is likely to be what? In fact, it's definitely pent. Now, the OH
second carbon atom, please.
Yes, and the double bond is
the
double bond is on carbon atom number 2 from here, number 3 from here. Then the OH is on number 3 from here, number 2 from here. So we can say pens 3 in 2 all. This is the best name we can give to it. Now Roman 2.
Oh, we can still give it as 2-hydroxypentool.
Yes.
In case of those that like to use the hydroxy name, it can be 2-hydroxypentene.
Pentene, yes. Now, I think the question, where am I now? This compound can be produced. Sorry, this compound can produce stereoisomers. Give the different stereoisomers of this compound. So let us give the stereoisomers of this compound that we have here.
Stereo simply means
this compound.
Most of them now will still ask what the meaning of stereo. Meanwhile, we just
I'm not the one that they're going to ask.
Hetero simply means the cis and the trans. So we are talking about the cis being two in all and the trans being two in all. That's
And
all.
that's it. So I should not be answering again.
So you are just inverting the position of this one when is this the position of this group. Once you invert the position of this group, the OH should come now here, and then this one and the double bond should come this other side. That will give the cis. This is the trans. The other one gives the cis. Once you up.
All you do is to
Okay.
change the position F. I think F is the last part of this question 5. So
Just interchange their positions and you have it.
anything you don't understand, feel free to ask in the comment section because by the time we close here,
And then some people are funny. There's not an optical isomerism in that particular isomerism. Because some people because looking at it, it seems like there's an optical isomerism where there's a middle center, for instance. This is not a group.
I need to know the conditions for
CH
optical
is
isomerism.
not a group. There's not a methyl group nor an ethyl group nor whatsoever. Prof, you can proceed.
Okay, so we'll now continue to the very last part of this question. We have the compound. Let me take it down. F says an organic compound with the formula CH3CHO. CH3CHO.
You will also answer this one this year. It's going to come.
Belongs to a homologous family of compounds. I hope I'm not obscuring. Belongs to a homologous family of compounds. Okay, of compounds. Yeah. What is a homologous family? In other words, what is a homologous series? A homologous family is a group of organic compounds having the same functional group, similar chemical properties, and successive members differ by a CH2 group or a molecular mass of 14.
All of that is important to give you all of that mark.
If you miss out one,
you
think that I'm saying it because I love to say all those things.
You miss out one, you have already failed homologous. Like I told you people, advanced level is not common sense.
They're asking you a definition for one mark. You are missing one word that
you
where
know,
would they see half mark?
You don't know. It is there. Want to see that it differs by what?
This compound can produce. Hey, how can I be going backward? State qualitatively how the amount of carbon and hydrogen can be obtained from this compound. So how can carbon state qualitatively how the amount of carbon and hydrogen can be obtained from this compound? It is very simple. You just have to burn the compound in excess oxygen.
That is it.
Burn the compound in excess oxygen. When you burn, what happens to carbon? Carbon will be converted to carbon dioxide. When carbon is exposed to oxygen, it becomes carbon dioxide, and then it can then be determined from the amount of carbon dioxide that are produced. Then hydrogen. What about hydrogen when exposed to oxygen? It becomes water. When hydrogen is allowed to combine with oxygen, it produces water, and then it can be determined from what the amount of water that is produced. So that is it for Roman 2. Roman 3. Yeah, Roman 3 and last. Another compound consists of. Are they asking for empirical formula? I'm not doing it.
Formula.
Who cannot do empirical formula here? I even thought that was a good question. So that's it, Prof. Yeah, the last question now. That number 6. It's even a very short one. It's less than 1/4 a page.
I'm just explaining. They should not take into consideration. I'm not going to go to the board because there's nothing to be written on the board. It is organic chemistry. I don't need anything to write on the board. The reaction scheme shows the table below shows the complete functional group and the names of the compound A, B, and C. You can already see A, B, C, D, and E that asks you to name everything. When I look at the first one, I'm seeing the presence of an OH, and that's a secondary alcohol. I've already named the functional group, so it is from what? OH. You are seeing C2H4O2. Don't go and tell us that it's a carboxylic compound. No, the carboxylic compound is COOH. This one is an alcohol, a secondary alcohol, and precisely when you look at that thing, that is ethanol. That is ethanol. Okay. B, C2H3OCH. I can see by an aldehyde, not a ketone. There's a difference between the aldehyde and the ketone. The ketone takes a double bond on the oxygen, while the aldehyde does not. It takes with a double bond on. Aldehyde take double bonds on. No, aldehyde takes CHO, while ketones take double bonds on oxygen. And looking at that one, we are talking of what? We are talking of ethanol. Ethanol. Good. The next one we are seeing there is acylic chloride. Acylic chloride. So that's ethanoid chloride. Good. The next one we are seeing there is a haloalkane. All haloalkanes are easy. Negative chlorine. And that's what? Chloroethane. That's what we had. Chloroethane. So that's where I ended. Now, reactions and conditions. Step 1 to 5. We want to look at the reactions and condition. In step 1, you are seeing that we are using what? Acidify potassium dichromate in the presence of heat. If you don't want to use acidify potassium dichromate in the presence of heat, what do you use? You use dilute manganese peroxide. It's the same thing. Now, the next one, this one is something that is easy. It's just the part we're seeing organic chemistry. That's PCl5. So it is PCl5. If you don't want to use PCl5, you use SOCl2 in the presence of coal. C to D is something that no student should fail, because when I look at it, I can already see a liter, and the only liter is what? Lithium weighty ester, aluminium ester. Is that it? That is LiAlH4. That is lithium aluminium ester. Now the other one is a reduction reaction, and we already explained the reduction reaction. With reduction reaction, it is an Markovnikov's rule. You will go only where there is more hydrogen carbon. Good. And the reduction reaction he explained before, even Markovnikov rule, when he was talking about oxidation and all the like. You're supposed to understand it, so I'm not going to throw any light on that one. I'm going to skip to section 6C. Good. In not more than 3 steps, show that the following conversation can be carried out: ethanoic acid to methylene. Okay, then I have to go to the board and show this equation. But without notwithstanding, thank you all for being into this section of the final revision A-level science 2026, that which goes for the academic year of 2025-2026. It was a pleasure having you guys online, and for my students on offsite, I'm really happy. We thank for the support and everything, although throw more warning to my online supervisor for the delay. Despite I contributed to the delay, I'm sorry for the wrong timing and the wrong schedule. And also to our medicine students at the level of academics, we thank you all for being with us tonight. I think it's a night where we are already at 2 o'clock, and it's precisely 2:30. So I would prefer all candidates to have a rest for 1 hour. But moreover to that, I don't see a candidate that is supposed to sleep. You study all night and you sit in the hall, you write, you sleep in the hall, the next paper comes, you write, and you go back home. It is a continuous process for 2 weeks. It won't kill you. You won't die. It is 2 weeks. It is not 1 month. So you won't die. I thank you all for being here, and I also extend a hands thank to the CEO himself, Mr. Godwin Yakum, who also participated, and also to push forward with the online classes. I don't know what I would have really actually done if it was to be me alone. It would have been something else. So we also thank the Academics Conviction, and we thank all our fans, and we say before you leave, please, the video will be uploaded. You can share, still comment, like, and subscribe, and advise people to come. We love you all. Have a blessed day and a blessed night.
It was actually a pleasure. I just want to say a very big good luck to all our students. You might be seeing me for the first time, but you are a student. Yes, so I want to say good luck to you. Believe in yourself in the world tomorrow. Believe in yourself in what you can do. Do not panic. You write, you've studied, you are up to that. So you write, and then we are waiting for A grades, we are waiting for success. So we need to celebrate success ahead of time. So good luck and congratulations to you in advance. We shall see again in another session, but for now, bye.
Bye bye.